as our session speaker. He holds a BE in Electronics and Communication from Anna University and an ME in a VLSI design from GCT Coimbatore, Anna University affiliated. And he is a dedicated academician with extensive knowledge in this field. And Mr. Mohan also brings a wealth of industry experience. He worked as a web developer at Mishware Technologies, Hyderabad, a verification engineer at CSOC Semiconductor, Bangalore, and a project manager at Key Technologies. Currently, he is also contributing as an AI development engineer at Vignan Technologies, showcasing his dedication to emerging technologies and innovation. T. Mohan, whose diverse background will provide valuable insights into today's session. I welcome T. Mohan sir to take over the session.
Yeah, thank you, sir. Yeah, so good afternoon, everyone. I hope everyone is
Mohan sir.
Fine. Is it audible? Hello.
Yes, sir. You are audible, sir. Mohan sir.
Yeah. So very good afternoon for everyone.
Good afternoon, sir.
Yeah. Thank you, Harish. So I hope everyone is fine. Yeah.
Yes, sir.
So let's we have no time. So let's start with our session. Just a minute. I will share my screen. Yeah. So cloud integration with embedded systems and AI. We know we all know that embedded system mainly it's mainly for a specific application point of view. Nowadays, if you look at any embedded system, it's very complex to previous one. There's the generations and the developments. When you look up the situations in the technology, how it is developed. Currently, the embedded system involved in every aspect in our life. In daily life, without an embedded system, we don't have any part of our life. I mean, any activity in our life, like a cell phone, whatever it is, from morning to evening, we have a sufficient tool. It's a tool, necessity tool nowadays. Let's come to here and our topic, cloud integration for in embedded systems. Before that one, we have a few things we need to know about cloud computing and embedded system a little bit. Of course, we all know all those things, but still, let's see what it is and go with things. Let's say now a system is connected. Any system is connected to net. Yeah. Full screen. Oh, it's not a full screen. Let me just a minute. Just a minute, yeah. Yeah. Yeah, now it's visible. Okay. Yeah. Now let you take any device. Nowadays, what happens means anything, like maybe a controlling a fan or controlling a AC, whatever it is, small thing, it can be connected to internet by using some small embedded circuits that can have some internet connectivity so that we can view that thing in the net. So we have internet of things that anything we can easily connect it to internet nowadays. Now let's come to here. For any embedded system, it's mainly meant for a specific application. Yeah. Let's look here. Uh, Even the cloud computing, if you see the cloud computing, what is there is we don't have resources. In past, what we do is we have a system, we have a software, we have a OS, everything, everything in our system. Yeah. So later, what happens? It's a cost effective. Why? Because if you want to do any some storage of data or processing, we need more space, we need more computation like that. And the hardware, networking, security, all those things become a big burden for a small applications also. So this cloud services became most popular in from uh, early 2000s to nowadays. It's most effective. Any application nowadays, it's through cloud only. We don't have any own desktop application, we don't have right now, because everything is a cloud computing, because we have a resources in the cloud. So when you have a storage data, there is a server for us. When we want to process your data, we have there is a dedicated system for us for any processing or storing a data or any visualization softwares like uh, some InfluxDB, Grafana, whatever the tools, high-end tools, whatever the things. So all available in the cloud. And the services are also very useful. Let's say when we want to have a software, our own, for example, we do some research applications, like say we have some MATLAB tools or something else. As an individual or a small team, we can't afford that much of cost. So what we'll do, there is a service, we can able to use that software alone. So no need of to install in our system to buy all the software. We just use and pay what we used. So such things happens nowadays. So that is a major uh, advantages now by using cloud computing. So what is there in cloud computing, if you see, is majorly as data storage, processing, and deployment. So what is there in actually in cloud means there is a huge big systems are there in some centers. There they use it for data storage purpose and processing of applications, everything. And they will do all the things. We just use the services and we pay that amount. And let's come to the embedded systems. We know it very well. It's mainly we say that it's mainly meant for a specific application point of view. Mostly, generally, we know it as standalone applications. Nowadays, it is an IoT, so it is connected to internet very well. Yeah, and if you see here the AI, this is also one more thing we have to consider in AI in embedded systems. For anything in previous day, we have to write a big algorithm. Any complex things when we have when you see any complex thing in applications, the solutions are finding it's difficult for us. Now, so due to invention of neural networks, machine learning algorithms, it helps us to do some sort of easy compared to previously. This AI will help us to predict and decision making in embedded systems. Yeah. Then one more thing is what we say, it's a cloud integration. That's our topic majorly. We know it, an embedded system is meant for a specific application. Now the computation of all the data is in cloud. What we'll do is generally we'll do the computation of data, storage of data, all the things in the cloud platform. So that is what we mainly highlight in this session, and we'll in this next slide we'll go deeper in that, how it is there, what are the cloud, how we integrate, what are the challenges we have, how it is in, and we'll see a case study also regarding that. So we just mentioned here what is the benefits of using the cloud And if you integrate that, we have a real-time monitoring. You can see the insights, and computation burden will be drastically reduced. If you do any processing at the system level, at the embedded system level, we need more hardware resources, memory, all those things. If you do it in cloud, what happens? It will reduce the computational burden. Of course, various challenges, and we have trends that we're going to see in the next slides also. Yeah, let's see. This is what I'm majorly considering next slide in artificial intelligence. Nowadays, everything in AI, whatever it is, AI for everything from the morning, the decision making, any suggestions in business point of view or in industry, agriculture, automation is running with AI. So now we can introduce AI in embedded systems. Of course, it is not now. It in previous decade it is happening, but right now it is in peak. In every embedded system, AI is there. If you took any phone or any AC, whatever it is, there is an artificial intelligence. So the intelligence makes us when to off, when to on, and making decisions, automatic. Modes, sleep mode, yeah, all those things. So this, and what is there in, you see here the role of AI in embedded systems. It makes helps us for analysis. What will going to happen? So that will be the predictive analysis, and in some case applications we have to take the right decision. This AI will help us to take the decision. Let's say in industry, is any furnace or temperature, at the temperature, the burner has to ignite. It's a real-time decision making. The AI will monitor the temperature in it automatically take a decision when to on and off in industrial applications or agriculture, whatever it is. Yeah. And one more thing is energy efficiency. This is what we can say is resource management is also one of the a major concern for us. Yeah, when you use an AI in embedded system, resource management also we need to consider. Let's say when we look at this here, a simple thing, whatever it is in embedded system, we have using sensors, we collect the data. Yeah, by using sensors, we collect the data here. Yeah, whatever, let's say an example agriculture field, we'll get the moisture content, yes, the temperature. Based on that we'll collect the data. For each we have some, let's say we have deployed 20 sensors. Each sensor will collect the data. Yeah, and with this data we'll have the decisions, because that data will give the some sorts in some 20 sensors is deployed in a field. When the water is flowing, it may not reach at the end also. It will take time, or sometimes it won't reach at all. So the data which we collected from the sensor will have those information. Then how we'll go with this means with the intelligence, by using artificial intelligence and insights in this. Yeah, what we'll do is uh, action intelligence means, what we'll do is means we collect the data, we'll process that data, and we'll see some analysis. How is the data? Every sensor is having some values? Is there any variation, correlation, all the insights? Because sometimes the sensor may not work, even though there is a moisture in the soil, the sensor may not work. Those things also we can consider. And how it is varying when you watering at the morning, how the soil moisture, when you watering at the midday, how it will be the data, and if you watering at the night, how it will varies. Based on that we can see some insights, how the data is collecting, how the moisture level in the field we can easily visualize. So those things we can check. Yeah, and that helps us for business transformations. what we collect the data from embedded systems or sensor data. We'll process the data and we'll see insights in that. Yeah, and we looked at any patterns because how it is there. If all the sensors are not getting any moisture content, what it mean? You don't have any watering. Of course, this example, what is the slide in the slide is example for any vehicle automation purpose. But what I'm saying is example for an agriculture point of view. And those things will help us for future business transformations. When you grow a crop, then the yielding depends upon the it depends upon the sensors data, how it is watered and what is the output. When you're watering at the night, how the yielding. So these things will have the information and will make us better understanding inside the data, the pattern of apply watering and the data information will help us a business transformations. How it means what to uh, what to grow in which area in which time, all the information we can get with this intelligence. Yeah, of course, what I said here, all the things by using of embedded intelligence means we embedded the artificial intelligence in an embedded system so that we can have the relevant analytics. We have relevant analytics of the data and we can enhance time to market so that what are the product that can be easily available in a short span of time. So time to market means for everything. If you see in olden days, if you develop any system or a application, it may take 2 to 3 months. The same thing if you develop right now, it may take 1 to 2 weeks only. This means the drastic how it reduced. And one more thing is productivity and efficiency is one more to consider. Yes. Now, by using embedded and artificial intelligence, we have much more importance. Yeah. What we can do here is by using machine learning algorithms like linear regression, decision making. Yeah. And this is NLP, it's a natural language processing. Generally, we have some LLMs, all those things are from the NLPs. We have some how we can have chatbots, boards, all things we can build with NLPs. And we have some voice recognition and speech synthesis also we can do with this. And with the computer vision, we can process images and videos. All the things we can use in computer vision, we can do all this image processing, video processing, all those things we can do it here. Then autonomous agents means automated. Let's see, what we discussed, what we seen in the previous slides means the embedded system and AI is very much important right now for any application. What is the importance of embedded system and AI in nowadays for any developing any embedded system? So we need to include the AI, and at the same time we need to process that data. So the processing of data and computation is a major challenge. We say the cloud. So what the cloud here in sense, in technical point of view, most of the cases I will use a layman term so that we can easily understand. In cloud, what is there means we have a system with data storage, means we have a systems of data storage. Simply means we have a data servers for storing data and for computing purpose. So computation means we need to compute some data. We need to process the data. We have systems for that one. Storage and managing physical systems dedicated for us. Everything will be available in cloud. So this all considered as a cloud. And if you see here, major characteristics of it, cloud here, on-demand self-service. What it means, what we need, we can use that one. So no need to get all the things. Let's say if we buy a system, we have a 2 TB of RAM and let's say 16 GB of RAM. Yeah, some other graphical, all those things. What happens? The cost will rise. What happens? The cost will rise. So it's all unnecessary in a starting situation. So what we need is just a system to run a program is enough, and there is a small data. So for that one, how much we use, that much is necessary. So for that, in the cloud, what we use, we pay for that one. So no additional cost. And what were one more characteristics here is we need a network access. For cloud, we must need a broadband so that we can easily access and we can easily send the data, we can process the data from by sitting remote in a home or somewhere in remote area. We can do all the computations and we can develop any system. And the resource pooling is very much what we say is resource pooling is. You can use it servers. Yeah, you can use servers, data servers, or any computation purpose storing of data. Let's say we use 1 GB of data. First we go with the 1 GB. We can expand later also. So here it comes with elasticity here. What it is, we go starting at the starting of application development, any application development, we use the cloud, we use the resources, what we need at the starting stage. No need to buy all the things at once. What happens if you buy all things at once, the cost will increase. A simple thing, if we need a 10 rupees of information, but we spend 100 rupees, the 90 rupees is utmost waste because we won't use but for a particular period of time. Let's say its duration of application is 2 months. At the starting stage, we don't use any services for 2 months. We just need a simple thing to installation, some hardware things, we're collecting all those things, and some developers, all those things. No need of invest more amount for up to two months. Later 2 months, based on the application, we scale the resources. Let it be a data or a computational. Computational in sense, it may be a GPU or a TPU. When you have any data, no data at all, no need to use of GPU because the first 2 months is meant for, actually it will take time to collect the data from embedded system. So after getting the data only, we'll do processing or computation of any AI or machine learning algorithm happens. So at the starting itself, no need of TPU and GPU at the starting because the collection of data is going on. So getting of all those things at starting it's a waste of money. So all those things. So whenever we need, we can use those things. So these are the key characteristics of a cloud. Yeah. Then what the services available in cloud generally? Yeah. So majorly we have in cloud infrastructure as a service. Infrastructure in sense, it will give the machines. We need a system. Yeah. For processing or developing an application, we need a system. So generally what we'll do is normally in our systems, we'll install an OS, let's say it may Linux or Unix or Windows OS, we'll install in our system and we'll develop an application. When you're developing an application, the RAM will not be sufficient. Now we need to upgrade our RAM. Let's say we have a 1 GB of RAM in our system, 1 GB of RAM. That is not sufficient to do our application. Then what happens? We need to upgrade. Means what we'll do? We'll buy a new RAM and we update our system. Let it be laptop or a desktop. we'll update our RAM to 2 GB or 4 GB or 16 GB based on the application. So what happens? The cost. We have to invent, we need to buy an hardware. And let's say the OS, what we are using, it's an Linux based system. And we are running a system with Intel 5, let's say. Now, to develop an application, we have a lot of resources involved. The Intel 5 is not sufficient to do our application. So what happens? We need to upgrade. We have to go for i7 or Ryzen 9 processor. What happens again? We need to change our hardware. We need to upgrade our hardware. All those things we need to do. So in cloud services, what they do is they'll use infrastructure as a service. Yes, we'll just with the laptop, no need of upgradation of all the resources in the laptop. We'll approach any cloud services like AWS or any Azure. What we'll do is we'll go with AWS services. Based on our application, we'll choose the machine, whatever the machine we need. We need high processing speed, let's say a 4 gigahertz frequency, having processor and a storage of 10 GB. All the specifications we'll prefer. Based on that, we have a charge. What happens? There is a charge. So we'll give all the infrastructure like our system. But most of the things will they go for, they will give a virtual machines. How it happens, we know it. We know when you install, I think we may aware of VMware, all those things. I hope. When you install a VMware, when you want to run any applications other than Windows, let's say Linux application, we need to build up any Linux applications. What we'll do is, our laptop is a Windows system. What we'll do, we'll install a VMware. After installing VMware, there in that VMware, we'll boot with Unix or Linux OS, and we'll install some Python or Jupyter Notebook in that, and we'll develop some application. So in the virtual machine, what when the hardware is same, virtually we're creating a machine with Unix or Linux system. Similarly, in AWS services, what they do is, based on our requirement, let it be a Unix system or a Linux system, we need some Linux system oriented system for developing an embedded application. We'll select there. We'll have an account. In the account, we'll use what are the services is needed for our application. Let's say I need a Linux application, so Linux OS or a Windows OS for developing an embedded application or AI application. Yeah, there I select, I need an OS with Linux OS and a system, a frequency, and which how much of memory, speed, all the things I'll prefer, and that will be provided by the AWS or Azure or Google or GCS. So of course there is a major role nowadays is AWS, Azure, and GCS, yeah, Google Cloud Services. So now we just pay the amount what we need. We use that resources. After completion, after utilizing, we'll stop the resources. Let's say we use for 2 months. Yeah. Then after that, we don't need. We can stop it. So what happens if you use the laptop and buy the resources, RAM or something, after completion of project, let's say 2 months or 3 months, what happens to the hardware? We have bought. It's a waste of money. So utilization of the resources with cost effective is very much. So now the cloud will provide infrastructure here. Means what? The machines, which are what the frequency, speed, memory, all the information will go with that. Similarly, here a platform as a service also they will provide in cloud. Platform as a service means we just give we don't have any all things, but they'll give only some provisions. Not in infrastructure, they give all the things. We can install whichever OS we need. We can install whichever application we need. Whatever it is, we can do. In the platform as a service, there is some constraint related. There is a limited resources. The installations of something, let's OS, and networking, all those things will be restricted in platform as a service. They give you a platform to develop our application. And whereas come to the software as a service, here they'll use the software for us to use the software for our application, not the resources of let's say not the resource in sense hardware resources. They not provide any hardware resources. They just use the software as a service. For a simple thing is let's say I developed a calculator. For simple example, in layman terms, I developed a calculator. You need to do any engineering calculations, a complex calculator that does all the complex things, so Lagrange's, all the complex algorithms that we can do, we can complex mathematics we can do with my calculator. So now we have to do those things. Now what we'll do is my software as a service for you, so that you use that software. You can log in into this website and you have the problem, mathematical problem. We'll post that problem in the software in the website, and that with your login accounts we'll post that mathematical problem, and that application will give the result. So now that service as a given as a service, that software I given as a service to clients. So that is what here software as a service. So why? Because we need to know this cloud services means when we develop any embedded and AI applications, we have to use based on the requirement, whether use as software as a services, any cloud services, we need to integrate in our application. We need to integrate. Let it be infrastructure, let it be a platform as a service or software as a service. So based on the requirement, we need to integrate. So when we have to know what are the services available, we can integrate it. So what are the benefits of using cloud here means we have a cost saving majorly, like expenditure what we drastically reduces, because we'll pay what we use. No need to buy. No need to buy. So no need of capital expenditure. And the scalability. What it means scalability means in starting stages we have 1 GB of data. So later on we may increase the data. Let's do to 10 GB. That can be easily scaled. So that is the advantages. Starting 1 GB, later on we need of 10 GB of resources, we can increase. Let's say in starting we have a speed of computation of TPU, later we can go for GPU or whatever the things we can change. We can reduce the things so that the cost will be reduced. And resource utilization is one more the thing, because what we need we use. No need of additional expenditure. So we can efficiently use the resources. So when you see at the point of view, in all the things, the major expenditure will be reduced. Yeah, whatever the innovation, everything. When come to the deployment point of view, in majorly this what is a public private hybrid means. In public means whatever it is that is readily available in the internet, everyone can access, means everyone can use it, the services. Whereas in the private, it will be only for the organization. Inside the organization, people only can use it, not outside the people. In the public, everyone can use it. In hybrid deployment mode, the organization members as well as the public access will also be there in hybrid mode. Let's see some artificial intelligence and machine learning, how it will be. For any machine learning algorithm, what we need is a data, because the data is much needed for any artificial intelligence, whether it's maybe neural network, a machine learning, a deep learning, whatever it is, they need a data. Yes, and with the data, what we'll do is we have to train the model. We need to train the model in different. It may be, if it is C, let's say this is a neural network model or whatever, any training model we need to build. While building instance, we write a program of a model, a structure model, and we need to run that program. So when we run the program, now we run that program in cloud. Where will run? In cloud, we will going to run here. In cloud instance, remotely there is a system. In that system, we'll run our program, not in our system. So we just log in remotely and we'll write a program. We collect the data, whereas in data servers, and we'll run that program in a cloud. Yes, we'll train. It's like a training instance. We have to give the input and output, and it will evaluate the errors, because in training point of view, it's need a more computation. We go for a TPUs or a GPUs is most necessary. But what we need is a TPU as well as GPU, because there is a huge data. It may be terabytes, 1 GB to terabytes of data will be there in some applications. When run that one, we need high memory, and at the same time high computation is required. So this all the processing, yep, all the processing has to be here. Yeah, we have to go with processing will be done in cloud. So nowadays, when you build any artificial intelligence, so generally we prefer while developing, we'll prefer cloud, not an individual system, not on a desktop. Yeah, whatever it is, we'll prefer cloud for developing any application. Yeah, in AI or even any embedded application. First, we use the cloud while developing, and later we deploy into the system. Yeah. So we have integrating based on the capabilities. Majorly, why we go for is lowering cost, ready-made configurations. What it means is, in cloud, there is a services, they are already trained models, built models are available. So no need to write from the scratch. We no need to write the whole program, whole model. So it is readily available there. We just use that model and we'll run with our data. Then accessing is very easy. There's a batch processing. It means if you see the computing and the container orchestration is very important, because different applications we need different environments. So that will be very in cloud. The container orchestration when to run means, in our application we have a data server in one container, in another container we have an application, it's web services while developing. All that can be easily orchestration means connection will be smoothly will be done. Yeah, and at the same time in cloud, in cloud, we is ready software as a service is available for us most of the time and quickly scale solutions. So when you integrated computing, AI, ML in cloud, we can scale the solutions, we can easily orchestration, there is a ready-made ML algorithms, and we can lower the cost. So where we can use a cloud service, we have the security. No need to generally what happens in the cloud services means they'll go all the things, the security, integration, networking, all the things they will do. So no need to bother about buyers. We just pay the money, they will handle all the resources what we need, we just pay what we used. So what measure we have impact means the data what will is the security, automation, then analysis, the business insights, now how the stock going on, or in an industry point of view, when to shut down the boiler or when to reduce the temperature, uh, and from analysis of employees or workers or the resources utilization prediction, all those things, then personalization and efficiency, then collaboration means all can be used here. Generally in a cloud, there's an administrator, developers of different resources and different resource persons will be there because one maybe you know about application development, the other maybe know about the data, yeah, and one may the customer or the client, all can be collaborated here in the services because they have their limited access. When you do an application, the user can use some their own data. Developer have their own restrictions of access and the scalability what we discussed earlier. We can scale the resources what we need. Yeah, this what major thing what we so far seen is cloud. What we use here, you can see the cloud computing where you have a storage, mobile, we can connect our desktop, and there's an application, databases, yeah, servers, yeah. There's a cloud, hybrid clouds where we can get the data from. There's an internet network connection between our cloud computing and hybrid cloud or public or private cloud. Cloud means some other systems in the network. So what we do is in the integration process, the process of connecting various cloud premises for our application. So when we develop an applications, we need a data, we need servers, we can access through our desktop. The clients, when you develop an application, the client will access through their mobile applications, yeah, and storage of data, development, testing, all can be done here in the cloud integration. Yeah. So let's say what generally nowadays, if you see majorly in the cloud, we have for data integration, application integration, and process integration. In the data integration, what we'll do is how the data will be stored and reporting, analysis, where to store, how much of data. All things about the data flow will go with data integration part. Application integration means when we develop an application, let's say agricultural point of view, for any agriculture application we develop any agriculture application. Let's see the yielding point of view. Yeah. Generally, the sensor will collect the data. We have an agriculture in different remote areas and different fields. In each field, we have a yielding in different areas. Let's say in Tirupati, we have agriculture field, and similarly in Telangana or in various states in remote areas, the climatic conditions. We have all the data in different areas. So let our application as business point of view, I need to procure the commodities from different areas, and we have to check all the things. I develop an application. So there I need to collect the data exchange and automation also necessary there, because collecting of data and processing of data and embedding into the application. Similarly, in process across different systems and applications. What means we have a data flow. What is the first step? That is the second step. That's the third step. All the things we can do in the cloud, means collecting of data. Then after collecting, there's an event. Then the other process will, after collecting of data, automation will be done to process the data, cleaning. And after that, after completion of data, we initiate the server or a service for resources, means a system, GPU or a TPU. Yeah, after collecting data, we use the TPU for building a AI application. So when you see step by step, one by one by then, so that can be done here in the cloud. So we have various things like Airflow, all those things will be available in the cloud. So that can be used here. Yeah. And integration approaches, how we integrate in various means through application program interfaces. Here we'll see, let's say we collect the data from agriculture field. We need to send data to the cloud, to an application. How we can send? Yeah. How we can send generally? That sensor has to connect it to internet. While sending data, we have to go through any protocols. Yeah. Here we develop an APIs for interfacing an application generally. We used to use that services. There is a provision. Simply in layman terms, we can say it is like a function. Let's say we write a program for addition. There is a readily available function addition. So no need to write the program for addition now. We just call that function for addition point of view. Let's say for any writing in a mathematical solution for any research application, we have an integration. Let's say we have integration and differentiation in that problem. Yeah. What we'll do is we no need to write the entire program of differentiation and integration. We have a libraries. There is a services available for interfacing. Use that libraries. There's a functions to use integrator or differentiator. We just call that function differentiation and that equation. Let's say differentiation of sin x or something else, x squared. That function will give the answer. Similarly, here in the layman terms, I used to say like that. In APIs, we'll write a program so that there's a different platforms will be there generally. Not everything in the same platform. There will be different platforms. When we want to send the data from this platform to that platform, we can't send it directly. Even though it is connected to internet, there's an APIs we have, so that by using that APIs, there is some protocols you need to follow, how to use that APIs and how to send the data in which format. It's a JSON or XML. There is different formats available for the data. We have to send that in that format to interface that application. Yeah, for our application. So that can be do here while integrating, because when you see the embedded system, it is not one domain. There's a domain knowledge, technical knowledge, cloud resources, data, everything. It's a team of work having a different domain knowledge. So some people don't know about the sensors, whatever the data, and some people developers knows about the only the data ingestion and data recruiting and only the data processing only. They don't know about the low level of the embedded system. How is the data? How it's going on? So what they do is they just write an interface, just collecting the data in some format. And in the embedded, at the end point of view, in the middleware, what happens, we'll write a program, we'll read the data from the sensor, so that what we collect the data, that data will be transformed in, we have to write a program in specific format to interface with the application, whatever suggested by the data developer. So now the embedded system developer in the low level has to write the program, use that API services. Now while sending data, they have some instructions given by the developer. We have to send that data in that format so that our data will be integrated to that application. Means we can send the data to the server seamlessly. This whatever the integration of already we have discussed the platform as a services also while integrating. So whatever the integrations in embedded system, when we want to integrate the data from the cloud, we need to integrate, because the data storage in the standalone application standalone was very small, because we continuously connecting of data will be there. What happens? Continuously the data will be coming from the sensors, and we need to store the data. So where we can store? We have restrictions. So that in the cloud services, let's AWS or Azure, we'll buy, sir, we use a data server. We'll push the data into that storage. So continuously. That data will be further used for processing, for analytics, for AI, whatever it is, we go for next. So first collecting of data and storing into the in the cloud. So here, what are the integration we see is platform as a service. Yeah. Let's see that majorly what we an embedded system here. It's a cloud integration. If you see any embedded system, whatever any system right now, if you look here, we just process the data. Any embedded system, any embedded, it may be industrial, agriculture, whatever it is, in any desktop applications or business point of view, marketing, whatever it is, it's a data. If an embedded application means we have a sensor data majorly. If in industry, it may be the sensors of a boiler, yeah, sensors of a temperature, like that. In agriculture point of view, it may be simple things. We'll say soil moisture, yeah, temperature, humidity, like that. Whatever it is data, based on what we'll do, we collect that data. We need to process the data. So in embedded system, the major thing is why we go for a cloud is we needed to store the data. We need to process the data, because in small scale applications, we can process the data at the end itself. Means at the small data means we can process at the end device itself. But in a huge applications, we can't able to process, because when you want to process huge data, we need high speed processor, large memory. What happens when you use that one? So generally it will increase the size, it will increase the memory, it will increase the cost. So the major thing is collecting data, storage and processing. So now in embedded system, what here is we need to consider, what this is the thing which we need to consider, right? Our topic, the data storage and the processing. We use the cloud integration for this purpose, because now with the data processing we can see the analytics and insights in the data, because this analytics and insights of the data can't be processed at the end level. We need a bigger systems, we need a TPUs, we need a GPUs, we need to store data in a data servers, storing of devices, buckets for storing data. So for embedded systems, what we need is storage and processing purpose, we need to cloud integration. Yeah, that is one thing. And next we'll see the monitoring and management. Whatever, we can sit in a remote and we can see whether it is working or not. Yeah, and we can see, we can control the data by sitting in home. We can control the machines, the on and off, whatever it is. So how we can control? We have connected that embedded system to the net. The net means what? Net, we have connected to the net directly. It is connected to your system? No, there is an application we developed in the cloud. Our embedded system or a sensor will send data to that cloud's application software, and we sit in a room or a house or somewhere in the remote. We log in through a application, and from that application we'll see the data which is stored in the cloud. Based on that, we have resources from the web browser. We'll have it on or off, or reduce the temperature, increase the temperature. When you switch, when you increase or something, or click by the mouse, when you click on that, what happens? Directly it won't control. It will go to the web server first. What you did, you'll get that information. Based on that information, it will generate some, it will again connect it to a remotely sensor device. It will send signals there. So when you look at that, the sensor embedded system is connected to net, that is called cloud, and we sit in remote through our laptop or a desktop, whatever we operate, that also connected to the cloud. So you see that remote monitoring and management happens in embedded systems, because sitting in this remote, we can see entire operations, entire data, what is going on in industry, each block, each department, we can see there. Yeah, so those things we can have. For that purpose, we have to go for cloud integration of embedded system. And at the same time, when we develop an embedded system, so generally need for sustainability also. It should not be if you there's a need of updatability. Like a simple example, when you took our phone, mobile, let's say the most of things are automatic updations. Why? Because there is a development. Yes, so when there is a development and enhancements are going on, so that can be easily updatable. For that purpose also, we go for cloud integration here, because when you develop an embedded system, it should be for a long run. It should be updatable. We need to enhance the data or enhance the features. We can do there. We can update the softwares. So for that purpose also, go for and AI and machine learning. In nowadays, everything is artificial intelligence. So in while building artificial intelligence, what we need is, while developing, we need to write the model. Model means a software model. Then we need a data. It will be huge data. Now we need to run that model, means training that model. To train that model, we need high speed GPU or TPU. It's morely 100 times faster than our laptop. in sometimes thousands and thousand times faster than our laptop. A simple example, let's say in layman terms, I will say a small application I did in my laptop of 1 GB of data. I run that program while learning. It took for me 2 days continuously run in my laptop. The same thing, I built that algorithm in Kaggle Cloud, in Google Cloud also. What happens? It just took me only half an hour. Do you understand why we need to cloud integration? Yeah. So for that purpose, for developing any algorithm for faster, all those things, the resources are available in the cloud. We use that resources for developing AI and machine learning. And seamlessly, one more thing is the user experiences. Whatever we said right now, that can be easily enhanced, and we can see the monitor and measurable. When you do it, we can see there how much time we use that processor, how much time we use that machine, how much of memory we used. If we use that one, we pay, otherwise not needed. All those things it will be clearly. At the same time, the interfacing, integration, when what happenings, data is, where is data, how it is going, all the things will be a very interactive. The user can easily do it. Let's say for example, now the operating any OS, in layman terms I'm going to say it. Now we know all that Windows is very user friendly. Why? But with the mouse we can click, we can open, we can close, we can run all those things. Yeah, in previous and 30 years before or 20 years before, not the Windows, if you see the Linux and Unix systems, when we want to run an application, we need to type the commands for running an application, storing an application, whatever we do, we have to do with commands. So now even the Linux system, Unix systems are also user friendly, graphical user interface. What happens? It will be easier for any layman member, this non-technical member also can able to see it. It's usually are developing, or if you say I am a developer, just click, run, collect, like this it will be there, click. It will be easy for us, no need to write an entire program. Similarly, for any non-technical person want to view the things, you don't know anything about, just it's a client, you want to know the things of what's happening there. You just click open and you can see that. So what happens? It will be user experience that can be, for that purpose also we go for cloud integration. So when any embedded system nowadays need cloud integration. If you don't use a cloud integration in our embedded system while developing any embedded system, so that will not sustain for future. That will be huge loss. It's a waste of money, because any embedded system should enhance updatability. It has to go for insights, predictive capability. All the things can be done because can be done by integrating with the cloud only possible. Yeah. So when you look at the components, is a thing we need to consider. Is there any embedded system, small device we connect to? First thing is we need a Wi-Fi, a cellular, internet connectivity. Let's say a fan, we need to connect to internet as a cloud. How we connect? Through internet only. So we need a device that has a Wi-Fi capability or internet or cellular, so that it will connect to internet. Yeah, so that thing we need to go for. And cloud platform. In cloud platform, what we are going to do, whether we collect and store the data, either we develop any AI applications or process the applications, or any management of all the entire application development, So for that purpose, which platform we need to consider? Only for storage or processing? So based on our embedded application, we'll choose our cloud platform. Yeah, whether entire platform we need or only a software, yes, only data storage, like that. And it's a major communication protocols, because in an embedded system, this is the main thing. Even though we connect it to net, we're sending a data to the cloud. So which protocol we need to send? If you use an HTTP protocol, it is a for large data purpose we can use HTTP. But when you go for with HTTP, what happens? The data bandwidth will be high, the time latency will be high. Yeah. So most of the cases in embedded system will prefer MQTT. So it's a lightweight data protocol with speed, high speed, because sensing of data, because we don't have any additional information, all those things there. We just sense the data and we'll send the data to the cloud. Because why we need a speed means in real time applications, because it's not to be very fast. For agriculture point of view, if you have some delay to 5 minutes, 3 minutes, not a problem. Let's say in industrial applications, what happens? The AI should be act very fast. Within the nanoseconds, it has to shut down. It has to get the signal to control the temperature, to control the boiler. Yeah. So based on the application point of view, we'll choose which protocols we have to go for. And the management of data, what type of services we can choose. Only whether we are collecting data only for visualization or when you for processing of data, that we need to select based on the application only. Let's say in an industry is a boiler. Continuously monitoring the boiler, the temperature goes up and down. Up and down. Even in the night, how it varies, in the day, how it varies, based on it, the boiler has to control the temperature. Now, the continuously it has to read the data, process the data, and analyze the data, so that the management can have a decision. When we have higher efficiency, they can view that we can process by analyzing, they can go for it. Or procurement of or inventory management or something, they can go for it in industrial applications. Let's say if it is varying, where something goes high, then automatically the inventory should be reduced or increased based on the cost, the inventory cost. So those things we need to analyze and process. So for that, based on the application only, what are the components we have to integrate. And one more thing is major is security. It is security. As look at here, the security is a major concern for us, because we connected to cloud, we update the data, anyone can use our data, anyone can attack our data, so that the data will corrupt, and whatever we develop, AI develops all the things, the entire output. The AI, for example, the response should be off, but due to this cyber attack, the response is on. What happens? The entire system collapses. So there is a breach in the cloud. So what we need is security is necessary. So while integrating an embedded system, based on the applications, we have to consider which type of device we have to connect, which type of platform we need to choose, which type of communication protocols we have to go for, what type of data management for what purpose we are using, and what type of security levels we need for authentication. While sending a data itself, there is authentication, it's a two-level authentication, encryptions, all those things we need to consider while integration of embedded systems, the cloud. Yeah, the key aspects where we have to go for it, why we go for means majorly is the data is collected for collection and monitoring is major key aspects in embedded system. Those things will be done with the cloud. Then remote control management, so we can view it from the remote and we can see manage control from remote area. That can be do with integration of cloud. And real-time analytics, so real-time we have to change the things. I said there is inventory cost is when a product cost is increased. Let's say for 5 rupees it has increased to 10 rupees. Now what we do in the inventory, whether to reduce the color buying of that product or increase, so that can be do with the real-time analytics. Automatically we can do it. And the cloud storage of data, scalability, and so these are the aspects we need to consider based on at the starting point of view, means while developing or training of our AI models, we need a high-speed TPUs, GPUs. Yeah. After that, we can reduce. We don't need of those things. So that can be scalable, and we can change the memory use, the speed, the machine we use. All those things can be scalability, and flexibility will help us in to select which machine and which data storage, how much data storage, those things, and the security point of view what we discussed. And here the models, here the edge computing models means edge computing in sense what it means in some real-time processing, the entire data will not be processed in the cloud because sending of data will take time. There is a latency. Some data has to be processed at the node itself because it's need a real-time controlling of machine or output. So some sort of where there is a latency and important data features, those things will be processed at the device itself, and the remaining after processing are started pre-processing at the device. The remaining thing will be done at the cloud. So if you look at here edge point of view, yeah, it's a device plus cloud. So the some data will be processed at the device in itself, and after that it will go for the cloud, and there will be computing will be done. So in edge computing, some sort of data will be computed at the device itself, and we have to consider aspects is what are the protocols and communication standards. Go for TCP or UCP and protocols HTTP, computing, COPE. All those things we need to consider here. Yeah. Then let's see in examples what nowadays what we discussed here. In some examples, a smart home devices, it's in cloud integration only. Whatever we have, we have almost all nowadays we have a security cameras. Yeah, so connected to cloud only. We connected our cams to cloud only, not directly to our system. We have connected to net in sense we are connected to cloud only because we read the data and we store the data in the cloud there. Yeah, and we use that process where, let's say, our lighting systems, everything in the cloud platform will store our data, will analyze our data. Now when we want to control the devices, let's say on or off, or fan or refrigerator or light, whatever it is, by sitting in front of a system or by viewing in the mobile, we just click and we go for it. Yeah, While clicking, what happens? We'll send data to the cloud because our software, the application software is running in the cloud. It will go to the cloud, and from the cloud it is connected to the device. That is, in homes devices, it may be a fan or refrigerator, a lights, whatever it is. Yeah. So that is what. Let's simulate this one more example: industrial IoT. Almost all IoT systems is a cloud integrated only. All IoT systems, but some things will use a platform as a service, some use a software as a service. Whatever it is, they will integrate the embedded system through IoT. Let's see the industrial point of view, the sensors, actuators are connected to cloud. And by sitting in the remote, the manager or a manager will be sitting in the remote area because the industry will be somewhere and the head office will be somewhere, and they can view the vehicle monitor. And with the industrial sensors, with the device, they can go for efficiency. How for the unit we have efficiency, all the predictive maintenance optimizations can be done by using somewhere. That application will be on the cloud, and by sitting on the remote, we'll develop that program because the developers will be somewhere else. The industry will be somewhere else, and the IT unit will be in somewhere else. The data will send to the cloud, and these developers have developed an application by utilizing that data, and they do the predictive analysis, and the manager will sitting in the manager room, and they can see only the output of how it is varying, all those things. As point of view, they can see how what is going on next for increasing productivity or business upgradations. All the things by the manager will view all those things. The entire thing what we'll see is by sitting in front of system. The entire thing is in the cloud. Yeah, the data is sent to the cloud, and the application is running on the cloud. Everything on the cloud. The wearable devices, what we have, right, the smart watches. If you see there, all the things, the entire data will not be here in our system itself. If you see in our mobile, almost in each mobile, nearly of as per the statistics nowadays, nearly of 1 GB of data we are sending by each man. See how much of data is going now, because that much we are using that. Every click, each application data, everything logs, everything will be in the cloud data. Even though of course that is differ right now, but what we see is the data will be in the cloud. So whether it's a smartwatch or a mobile, it is connected to cloud only. Then automated vehicles. It's a ship. That ship is navigating where it's going on. Everything is not directly connected. It will send to the cloud. Means there is a system. The information of navigation where it is going, that information is sent to that system. The system is storing all the data of navigating one by one. In sense, tracking of the vehicle. Tracking of the vehicle and the diagnosing way, remote diagnostics. In sense, nowadays the system is how we develop in autonomous vehicles is, if there is any problem in the system, it may be a bike, car, whatever it is, with just one click, the data will be loaded of our device, our vehicle, the engine parameters, valve, throttle, brakes, oil, coolant, everything will be loaded. The data information will be loaded in the cloud, and there with the data, it will run the program, and that program will diagnose if there is any problem in the engine, if there is any problem in the coolant system, is there any problem in the AC. By sitting in your in your mobile, we can see by diagnose your vehicle, you can look at here. That can be done nowadays with the cloud integration only. Yeah, these are the examples where we can see in AI, majorly you can see cloud integration in AI, major things is This is the thing we need for AI because there will be huge data, nearly in GBs, terabytes. When you run a program, it needs much high speed, so nearly 100 times faster than our system. In sometimes one system may not be enough. It may run on distributed environment because one system may not be handled while training because it may be huge data, terabytes of data will be there. You want to run that program, train a model. How it possible? It has to run on a distributed system. Distributed computing means that is a different concept, but of course the data has to be run on 3 to 5 systems there. For simple example, as saying it's a cluster of systems. Let's say the larger what we see is GPUs. We know it, Gemini, ChatGPT, all those things. When you look at that one, those are developed on distributed environment because the training of that LLMs are very huge because it will do everything for you. How they trained in one system? Not at all. It is not sufficient because they have trained nearly of terabytes of gigabytes of data. Large language models, the ChatGPT, Gemini AI, whatever it is, large LLMs, they are done with cluster computing, means that is distributed on a computing platform. These are where it is a cloud only. So the cloud computing infrastructure is very much essential for AI applications. Scalability resources. So if you look at here, you see the GPUs and the TPUs for computing. While training a model, we need a GPUs and TPUs. I said that in a laptop, when I run a program, I run it run nearly for 2 days. The same thing when I run with in the cloud in GPU, it took only for half an hour for me. Yeah, so that is what I mean, and at the same time handling large data sets also. So when look here, these two things has to be considered. So scaling of computational resources is very much while integrating AI because there is an ML, neural network models, a deep learning, Excel. There's a lot of stack. Deep tech stack has to be computed, and it has to handle large data sets. And in sometimes not everything is needed while integrating. There's a pre-trained models available. Pre-trained models. So that what happens? We'll use that one. The service provided in AWS or Google, they already developed some systems for, let's say, object detection. They have a service. Now we no need to train a program for detecting objects, all those things. We use that model for our AI application in embedded system. So what happens? The time reduced majorly is the pre-time models is time reduced. So in the while cloud integration in the cloud services, we have a cloud AI services here. Yes, for image point of view, we use that model. No need to train again and again. We use that services for our application so that we can drastically reduce the time. Yeah, this is what the integration depends. In the first case, we have seen everything with the competition point of view we have seen. Now the pre-trained models. Now deployment and development. So mostly in cloud-based development tools. Enters as developing, deploying, management. As a developer, where he develop? He develop in our system? No. The developing environment is also in the cloud. And the testing environment is also in the cloud. And the production environment that also will be in the cloud. After developing the production, it will develop to the deploying into the production environment. The entire environment, production, testing, developing all the things, how it is going on, automation, all the things, managing everything AI can be done by using streamlined process. one by one, developing, then deployment, then enhancement in the development, then again into the production. Streamline. So first developing, let's say for example in layman terms, I developed for 1 week two features, and now in the production I use that few features are added. It smoothly runs there. A simple like that. And again in the next week I developed one more feature in the development environment. Now I integrate with the production, means in the live I use one more feature. So we no need to build at a time. We enhance one by one, developing and developing, and the management of all those things. Of course, what we discussed right now, we say it's a DevOps point of view. Yeah, everything will be smoothly handled. The data, when to integrate application, updation, production environments, all those things. We have deployment tools. Yes, it's a main nowadays. It's a major things of now embedded system developer no need to go for it. But when you took as a whole, an AI integration or any application development, there's important role of DevOps also. And in some cases, there's a simplified development. No need to all those things. Just click, 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 and go. So based on our application, we'll choose the deployments also. Yeah. Similarly, data integration. What are the data resources? Various data resources for processing a different system, and pre-processing and transformation, because the data we collect, first we need to clean, transfer and prepare data for AI model. So starting of data from what we get from the data, and integration of all the data, because the data is not from one thing, it may be from different scenarios, with different sensors and different customers and different type of data. All things has to get collected data, and different formats also. Maybe the data will be in Excel format, in JSON format, yeah, in YAML format. So different formats, different protocols. We need to integrate all the data, and we'll store in some data will be in SQL, in some data will be in Snowflake. We need to collect the data, integrate, and yeah. So the data integration also, management also, we need to consider. And you see all the things what you see, it's facilitating collaboration. If you see in the cloud, some developers some access, some resources have some more access. Yeah, developers, stakeholders. So for developers, they have some limited access. Stakeholders have some limited access. As users, we have some access of data. When you, as a developer, I have access from only few resources. AI developer, we have some access to the resources. So these all the things will be given in the cloud. When you have a AWS, there is a user. Say, let me the user, the cloud, and when you are building an application, you are the custody, you are the entire thing, you're the administrator. I am the developer. What you will do is you will use the resources what I can access. I can access the data. I can access only this application only. So that you can permissions to me. So that can be here is such shared access. Sometimes there is a shared access, limited access, reusing of models. All can be done by using cloud integration. So when developing, we have to consider all these things, which one to use, which one not to use, based on the embedded application, because it's not a one-man show, no. It has to be a cloud engineers, customer, domain knowledge, AI developer, everyone has to, based on that, there's an architecture. Based on that architecture, what are the resources we need while integrating to the cloud? All should be considered. So the best examples, what we see, what we discussed here, no? If you see image recognition, it's a cloud-based image recognition APIs. Sentiment analysis, where we can see generally, or chatbots, all those things are NLPs. Then predictive maintenances, equipment failure, this in the equipment failures, and in, let's say, simplify things. Apart from the embedded, I say stocks prediction, that also built in cloud only, in AI in cloud. But it's the stocks is not in embedded, but I'll say the cloud integration in AI examples. Let's say a simple case study how we can handle. So what we discussed in the cloud integration, with a small example, we can say there's a agriculture irrigation. But what you see is here, what the challenges we have here is inaccurate data. What we have is inaccurate data, the locate sensor prone to errors, requirement of calibration, frequent, then lack of real-time monitoring, because the farmer can access data periodically only. The changing weather conditions that will be differ, insufficient water usage, and limited scalability, because they can't increase, the local infrastructure is very limited. Now what we said is we don't, without the cloud, we am saying without cloud. So we need to overcome these challenges. So what we need to do is the case study. So with the cloud integration, what we are going to do now with this inaccurate data, real-time monitoring, the inefficiency of water usage, and the scalability of resources, because when you develop in a local infrastructure, the resources are limited. What we use, the processor is same, we can't change. We have a RAM speed same, the processor speed is same, it won't change, you can't increase, you can't decrease, it is limited only. Yeah. So what we do, we need to upgrade the embedded system. What we need to do is we need to connect and added Wi-Fi connectivity for each sensor. What we'll do is, when you look at this case study, we need to connect that each sensor to upgrade that system by connecting to the net IoT. Yeah. Then edge computing. I said in edge computing, some data has to be processed at locally only, and reducing the amount of data transmitted to the cloud. So what we'll do is we need to upgrade the embedded system, that each sensor node is connected to net and reliable sensors has to be net, and edge computing has to done, because some data has to process it locally to reduce the data transmit to the cloud. And the cloud platform, we will go for Azure or AWS. It's a cloud platform with IoT services we'll do. So what we do is whether we go for AWS or Azure IoT to handle device management. Now what we'll do is we'll read the data from the sensors. From sensors we read the data. Some are processed locally and we'll send the data to cloud to handle it device. So now the data is ingested and stored. Ingestion means data from the sensor to the cloud. That is what ingestion. Coming from sensor to cloud server is injection, getting of data. And storage, storing, where we are storing. And after storing of all the data, what we collected from the sensors, we go for data analytics. We do the analytics, AI models, of censored soil moisture and weather forecast. Now we collect all the data from the sensors in the agriculture. Everything, soil moisture, temperature, weather forecast. All things data are collected continuously. Now with the data, we'll build an AI model and we look into the insides of the data, how it is varying, there is any correlation, and we'll develop an AI model for prediction of uh, what type of crops we have to go for next, all those things, because now this analytics and AI is very much now we integrated AI also in our system. Yeah, that will give the provide a real time irrigation and recommendation of farmers. Yeah, so that can be done by integration of this. And one more is user interface. So there is a web and a mobile application. We'll develop a web server there, and there is an app in our mobile. So through that app, it is connected to the web server. The web server is again in the cloud. So we can view the real-time data. The farmer can view the real-time data by sitting in the remote and receive irrigation recommendations also to the user and control the irrigation systems from remotely also. You can control the pump to how much time it has to stop or stopped or on it by sitting remotely. The user interface. So if you see the cloud integration, we need to update the sensors and sending of data by edge computing and the main handling device management, ingestion of data and storage, and integration of AI, cloud AI, and the user interface. So what we saw the challenges that we overcome by using these solutions. So what are the technology stack we need for this? Beside the solution, how we do? We said here we need to upgrade edge computing, cloud platform, AI, user interface. So what is the technology stuff here? What you go through? So while sending the data, how we'll communicate the data from sensor to cloud, from sensor node to cloud. We use a communication protocol, MQTT, STP, whatever. We use MQTT protocol, and we connect it to sensor through Wi-Fi connectivity. Yeah. Yeah, of course. No. Hello. Yeah. Hello. Is there? Yeah. Is there any queries? Okay. Then I will continue with this. A cloud platform for service data storage and a backup capabilities, and the data analytics tools which is available in the cloud.
మీది ఎంత మొబైల్ చెప్పు.
Hello. Yeah. Hello. Yeah. Can. Hello.
Proceed, sir. Please proceed.
Yeah. Okay. Thank you. Yeah. So if you see in the previous, when you look here, what are the challenges we have seen? What are the solutions we need to do? And here we just set the solutions and we'll see in the what type of technology we have to go for. We need to connect the device with Wi-Fi. Either we can connect with the internet or we can go for LoRaWAN or a Bluetooth, whatever it is. And the communication protocol, we could go for HTTP, COAP, or MQTT. Here we go for MQTT. And the cloud platform, what we said here for platform services, we need to go for handling device management. There is a services available for services for data storage and AI capabilities. And the analytical tools are readily available in the cloud. So no need to write everything that is available in the cloud. So if you look this case study, what are the problems earlier we saw in that embedded system by integrating with the cloud and also AI, what happens? So drastically we overcome those challenges very well. We have a real-time monitoring, real-time controlling, recommendations, and there's a scalability. We can do the computation with less cost. Everything we can do with this cloud integration here. So whatever here, with this, what happens is these are the benefits with this. Efficiency is increased because waste of water is reduced. Increase in crop yields, reduced manual labor, and the real-time monitoring and control is possible. The scalability is available here, and because the larger farms can be monitored, then sustainability impact means the system what we designed, embedded system, that can go for live longer periods, means that can be used for nearly 5 to 6 years without any damage. And after 5 years we can enhance also possibilities. The one more thing is the security is crucial. What is some lessons is a security, a data quality, and the feedback, user feedback, so that enhance for the meets their needs. So with this integration with the cloud, the successfully overcome the limitations what we see, and we have a more efficient irrigation solution. So generally, even though when you integrate with the cloud, we have a challenges. The main thing is connectivity challenges, because the connection should be continuous, because it will be in the remote area, constrained environments. The embedded system has to send the data continuously. While sending data in real systems, what happens? There will be a latency. In real time controlling, what happens? It should be very fast. So there is a possibility of latencies. This is the key challenge, because the sensor has to sense the data and send to cloud. It will take time. Sensing of data and sending through Wi-Fi to cloud, it will take time. Connectivity should be the challenge. Then when there is some sort, then offload of cloud is a problem. And one more thing is power consumption. This is one more major challenge here. As the cloud increase the power consumption, not ours, I have said, but when you use the devices in embedded system, what happens? The sensor has to run. There's a Wi-Fi device. For both things, we need a power. So battery operated embedded devices, when continuously running, what happens? It will consume more power. Then we need a high rated battery power supply. And one more challenge is here is security and privacy is one more biggest challenge for us, because the data what we transmitted in the cloud, even though we have authentication, there is a critical concern should be addressed here. And though we have the more, when we integrated embedded system and AI with the cloud, it is a major use for us. The development time to market, cost, enhancement, sustainability, everything will be increased. But still, we have a major challenges. Of course, that embedded AI, what we discussed here earlier, AI is embedded in a system. What we see is it's a simple thing only. We embedding AI in our embedded system. So generally what happens, now the AI is running in the cloud. In some applications, so tiny ML programs has to be deployed in the nodes itself, so that the real-time there is a sensitive data will be there, need to process at the device itself and need to give the control there itself. In such cases, we need quick decision in the node itself, So generally what we discussed earlier in the entire PPT, I said that the AI is in the cloud, the model is in the cloud, the model run the cloud, and will send that in decisions. In some cases, it may be some industrial or vehicle automations, the AI in the device itself. So there is a constraint again there. Memory computation is a major constraint there. So generally we go for a tiny ML, it's a small ML program, not for entire thing. Whichever is important for the data only, we go for embedded AI. That means what is the AI model is deployed in the node itself. If you deploy AI in the node itself, there is a problem again, because the computation it requires more power, it requires more memory, it requires uh, um, high speed processing. Yeah, even though it is helpful, but still there is a challenges with embedded AI. So where we can see that embedded AI applications majorly in healthcare, because in healthcare applications it should be taken there its suggestions, not in the cloud and can get back to us. Yeah, in energy embedded artificial intelligence. So there are also similar things when you're monitoring on the grid, when getting out, when we decision has to be taken there itself to stop the grid, or there's a uh, wind blades has to be controlled because there is a deviation in the angle of the blade, it has to be adjusted, it has to be done there and there itself, so that we have the efficiency. So like this, in embedded AI, if you see the AI applications, mostly in healthcare, energy, logistics. So there and all we used embedded AI applications also. Yeah. So of course, in most cases from the starting to now, I just continuously spoken, saying all these things. I don't know whether you understand it or not. Let's have any queries regarding this so that I can have interaction with you, so I can liberate what you understand and what you have doubts. Let's clarify here. Any queries, please? Hello. Yeah. Hello. Anyone? Any queries regarding this? Because I took, of course, I extended the time. Of course, the next session is also mine only. Even though I think maybe the voice, maybe clarity is missing because of my health issue. Anyhow, I hope I briefly looked insights of cloud integration in embedded and AI, embedded systems and AI. So wherever in necessity we have to go for cloud services, we need to choose a platform as a service or software as a service or infrastructure as a service for our application, and we have to check whether we go for real-time analytics or monitoring, data storage, data processing, yeah, and the user interfaces, web server, all these things we need to integrate it for our system, entire system. We look at the entire system with the AI, with uh, cloud services, we have a better solutions. Yeah. So can anyone please any queries, please let me know. So better understanding. Hello. Anyone please?
Hello, good evening, sir.
Yeah.
This is sir.
Uh,
Sir, I have a small doubt, sir.
yeah.
We can suggest for the students projects, BTech projects. If we take embedded AI interface, so is it
Yeah.
going to increase the project cost, sir?
No, that cost depend. The cost in sense here.
Because if you want to take AI application, we need to have more computations and so much of memory required. That's what you.
Yeah. So let's see, when we want to include AI, embedded AI,
Yes,
we
sir.
need to run the program AI model in that device itself.
Okay, sir.
So, in generally, if you see, for example, you know the Arduino,
Okay.
yeah, Arduino, Raspberry Pi, Raspberry Zero, Raspberry Pico. So this is a lot of, because we know these things, that I'm going with these examples because most of the people know these things. Yeah.
Yes, sir. Generally, students are going to
Ah,
use the same
I
microcontrollers only.
I'm coming to that only. When you go for Arduino, it is not capable of doing AI
Okay.
because there is a limitation in the memory, there is a limitation in the computation, running the program. We don't have enough memory to run the program.
Okay, sir. That's
AI
what my
model
doubt is actually. If we want to suggest for the students for including the AI in that model, it is not suggestible for the students' projects
no,
because
we
of.
can suggest, we will build AI there because some things, some situations we need to build in this,
Okay.
in health, in industries, energy. It must, because quick decision has to be taken then and there itself, not in the cloud.
Yes.
So,
Okay.
but when you use that one, it will increase the cost because the Arduino, what we said, that the Arduino is not capable of computing AI. But if you took the Raspberry AI or Jetson or Galileo, what
Mm.
happens? Intel Galileo, Jetson boards. Those are capable of computing AI. So we need to use that one. If you see Arduino cost, so generally it's nearly hundreds. When you go for a Jetson or something, it's nearly about 6,000 to 7,000.
Oh,
Not only that one, we need to buy a SD card memory also. And again, its cost.
okay.
Everything will be drastically increasing. The connection of the things, everything will be going to increase. So based on that, based on the application, we have to choose whether we go for it or not. Let's say for agriculture applications, for example,
Mm.
agriculture applications, no need of embedded AI there itself because it to take a few minutes, not going to be waste anything. Yeah, if it
Okay.
took 2 minutes, there is not a problem because
Mm.
the data will go to the cloud, and after processing that will become here for controlling data. So with that controlling information, it will control on or off something else. It may take 2 minutes or 3 minutes or 4 minutes or 5 minutes, something else. It's not going to harm. But whereas in industry, it's boiler leakage is happening, the data goes there in the cloud and there it computes, and that AI model will find out there is a leakage in the boiler and it has to shut down. It will take a 10 minutes. What happens?
So
It's
already damage is going to be
yeah, yeah.
happen.
So,
Yeah. So
based
such type
on,
of critical applications interfacing with AI is going to,
yeah,
it's
yeah,
not a suggestible idea.
yeah. So
And
based on,
also for students projects, because of cost effective, so prototype model building, it is not, we
for
cannot
students'
suggest.
point of view, we can do, for students' point of view, not a problem. They will do
Okay.
a prototype model only, no? Not a real time.
Okay, sir. Okay, thank you.
Yeah.
Thank you, sir.
Yeah. Yeah, is there any? Yeah. Hello, any queries regarding that? Yeah. So let hope I understand you understood things. Let's close this session. So thank you for this one. Let's have it a few minutes break. Yeah. So
Yes,
that
sir.
we can have a next session.
Yes, sir. Thank you for your insights in cloud integration with embedded system and AI. I thank you, sir. Please take an 5 minutes of break so that you can
Yeah.
continue next session. Dear participants, please stay on the line.
Yeah.
Be continuing the session. Thank you. Please stay on the line. So welcome back, sir.
Yeah, hi.
It's enough, sir. Shall we continue the session?
Yeah, is there, okay, means I will continue.
Okay, sir.
Yeah, we'll continue. Yeah. So in previous we have seen the integration. Let's see now the sustainable design in embedded system and here. Of course, the sustainability is very important in every life in any country, whatever it is. the sustainability is very much important. For any system or life in economy or any country, resources, whatever things. Now let's see, here we discuss with the two aspects, how the sustainability with embedded systems and sustainability design of an embedded system. In two aspects we'll see the BPIT, this session. One is how the sustainability achieved by using embedded system and AI. And the second one is how to design an embedded system which is sustainable for a long period. So those two things we'll look in here in this session. Yeah. So generally, and nowadays AI sustainability in generally, if you look here, the cases for financial and non-financial benefits across industry. So when you use AI, it should use for financial and non-financial benefits also. And at the same time, sustainability of AI. Do you understand here? AI can be used for making decisions, what to do, what not to do, reduce the cost by using monitoring. What you see in the previous session, we use an embedded system for mainly purpose controlling, decision making, all those things. So what happens? The cost can be reduced by using any AI. We can see the case study. What we see in the case study, if you see that case study, there's an increase in efficiency. You have reduced the cost, increase in the yield. So by using artificial intelligence in that agriculture case study, it increases that sustainability of the agriculture. Means there's a productivity, recommendations, everything will, the cost reduced. Yes, all the benefits we have seen there. Similarly, the sustainability of AI means what we developed an AI model that can be used for prolonged manner. If we develop an AI that can be capable of using for tomorrow also, not for today itself, that model is sustainability or not. So that also we are going to discuss here. So nowadays, those things, the sustainability of AI and AI for sustainability, both will be considered here. Yeah. The same thing for embedded system also. So majorly, if you see here, when we design in a sustainable design in any embedded system, that should be a very, the impact should be very minimum, whether it should be energy, materials, efficiency. But what you understand, what again it is, you go with impact of energy, materials in sense. If you use in an embedded system, the hardware, if you see there, we have in ICs as sensors. How they manufactured the elements is from the environment. They'll processed it. They prepared an IC. Yeah. So inside all those things, it took time, cost, and when that device is meant for today, not for tomorrow, what happens? The entire thing will go into waste. It's not a sustainable. Yeah. So we have a provision while designing that system can be used further also, not for today. It should be the lifespan should be increased, not for tomorrow and future also. So that should be like that. And energy. Now for computation of data, it requires power. So when you use a sensor, it requires power because it senses the data and convert into digital data. It requires power, and while sending a data to the cloud, it requires power. Yeah, through Wi-Fi, whatever it is, it utilizes the power. From where it will get? We need to go for batteries. Some batteries, from where we'll get the batteries? Again, with the manufacturing. The energy efficiency also impact. Yeah, how much energy we are consuming. So unnecessary of wasting of energy is also not good. We have to use a friendly energy like a solar, and we have to reduce the consumption of the energy also. What you do? We have to reduce the consumption of the energy and the materials what we are using for the designing of the system. So that should be eco-friendly, because when you nowadays, if you see the previous laptops, old laptops, what we are going to do now? The Pentium 3 is there, Pentium 4, or 80186286 processor are there. What happened to them? It's all waste, e-waste. We don't have a process, again process it to and get the elements back. We don't have that such technology still now. It's on research, because the sustainability is very much needed for human uh, longevity and living process. If you see, for example, uh, when the going on, the resources will deplete. If you use resources, for a best layman terms example, I go for sustainability. Let's say Dubai, they are rich in resources of oil. Everyone knows it. They are rich in resource. They have main resources oil. Now they have oil. They can earn money much more. If the oil resources are depleted, what happens? Of course, the example is not related to here embedded system, but it is related to sustainability. What happens? The country will collapse with the economic. Today they have good. What happens next? The best example, already it is in South Africa. We have some uh, likes of Congo river. There is a country there where there's Shell. You very well know Shell petrol. Yeah, at the starting stage, there we have huge resources. They they have high economic. They are a fully developed country at that time because they have more money. But later, what happened? Now you see it's a poor country because the resources are depleted. They are contaminated. Actually, the water is contaminated there. When you look at Dubai, if you see the Dubai, what they are doing is they are concentrating on majorly on real estate, then tourism. Why? If this depletes the tourism, then real estate will boom, so that we can see the towers, palm tree, like that. We see most of the things in Dubai is meant for sustainability of tomorrow, because the resources, oil resources may deplete at one stage. How then they can earn money? So that they use that money now for that. Similarly, now in this case, what we are discussing now, any design we develop, that should be sustainable. Yeah. And you can see the sustainability technology, what we design in AI, that should be the technology should be used for tomorrow. So we have to develop in such a way that should be prolongevity. That can be not now. It should have some decades have to be used that technology. Otherwise, what happens? Today, one technology came. Let's say some AI technology. With that AI technology, we have built all the devices. Tomorrow, technology C came. What about the technology B then? Is a technology B? All the devices are built on technology B. Today, it's working fine on when. Now there is a technology C has came, which is more efficient, more fast, all those things. What about this? The cost is fixed. So when you develop any technology or something else, there should be sustainability, conservation of resources are very much needed. Similarly, the systems and AI, it's a role of mainly energy efficient, smart solutions, eco-friendly innovations are much needed. Of course, it is an ethical point of the sustainability. We need to consider an ethical point of view for human, because it should not degrade the humans, degrade the environment, because we have to live in the world freely, happily, all those things. It should not reduce our longevity, our span. our cost, money, economy, resources. We should not deplete the resources. In such a way, we have to we need to design the systems actually. You see what matters in sustainability majorly. You look here, climate, technology, carbon emissions, electronic waste. In previous, what happens? We use the automobiles, diesel cars. Nowadays, there is no diesel cars, only petrol cars. That because climate. If you see similarly, the energy consumption in AI is very much significant. Efficient designs are necessary. It has to consume less power. Then ethical innovations are necessary. Because while designing any system, we have some social responsibility is needed. Because with that system, there should be a sustainability. Yes, these things really matters for sustainability for a human and even for the embedded systems. Because the carbon emission, what we say, whatever it is, the ICs, PCB, it will be the waste only at last. When new technology came, it will go into the waste. It will be impact on the climate. All those things we need to consider here. So what principles? What generally we need to consult is what here is. If see total sustainability, we have to design sustainable designs, sustainable materials, what we need to use. And while design, the durability, how much days it will live. It should be, if you design something, it will work for 2 days, then for the third day, what we'll do? Again, you need to construct new one. Again, it's a cost. So while designing itself, we have to think that there is a durability. Yeah. This is much needed for embedded system design also. And then energy efficient. If you design a system, continuously, let's say the energy efficient, how will do the energy efficient in some cases? For example, for agriculture point of view only, we'll say, we'll send a sensor data frequently, let's say 5 minutes, 10 minutes like that. In meanwhile time of the 5 minutes gap, the entire power to the system is waste. So we have a sleeping mode means what? It will be sleep mode, so the energy will be low consumption at that time. When processing, it will requires more power, and in the sleep mode, it requires less power. So what the energy budget is necessary and efficiency and the waste management and designing in what way we are designing is also important. So that should be impact on the climate. That also we need to consider. It should not. Majorly these things are considered while doing and developing any system, not only embedded system. So generally considering all those things. I said we are looking in two aspects. One is sustainability by using embedded systems and sustainability of an embedded system. Two aspects I am going to discuss right now. One is any system by using cloud, we can have sustainability. For example, there is a logistics door delivery system of parcels. So the man has to deliver the products to all houses according to the list. So in previous, he manually moves with the bike and he delivers all the products to one house to one house like that. In some cases, the A will be at one end, the other will be at that end. In the middle, there is a one more. In the other street, there is one more house like that. Some zigzag way. Let's say it is in there is a streets. There is a street connections like this. There is a houses here. Yeah. The delivery may has to go like this. You deliver here and you will get back to you and deliver here, and you will come to here, you deliver here. Like that, you will do the parcel delivery. Now, what happens? There is a huge consumption of energy. Here, energy means fuel consumption. Now, with the use of embedded systems, after getting address of the delivery address, with the delivery algorithm, there is a route map will be there. Route map. With that route map, what happens? First, which one has to deliver? Second, which one has to deliver? So that there is an energy efficient. Now, we designed a system for delivering of products. So now this embedded system this AI system will give the route direction of the delivery boy so that he can cover all the deliveries by reducing the energy and the fuel consumption. So this is a case where our embedded system will help for sustainability. Yeah, and one more second case why I said no. Developing a system that is sustainable. So when we design a system, in the case study, we have discussed two things. First one, the challenges, what the local embedded system for farm monitoring. It is not a sustainable design. And next, after integration with the cloud, that system is sustainable because that system can be used for enhancement, that can be used for other developments, future extensions, and we have better yielding. So that what you see in the previous session, that agricultural example case study, that is example for sustainability of an embedded system. And this routing algorithm, what we say delivered by, this is sustainability by embedded system. Yeah, that's what we need to develop in sustainable development. We need to consider view of social, that should be ethical, environment issues, then economic issues. So these are main things while designing an embedded system. That should be cost effective, environment consideration, you should not harm something. Yeah, even though if you see you're using the mobiles, there is a harm, there is a good and harm. Then we evaluate with good and bad, which is better. So with that, we have to choose things. The environment considerations, economic point of the cost, increase or decrease. All these things we have to consider for sustainability. Yeah. Where we have sustainability. So where you can see here algorithms, we use any artificial intelligence. So power for energy supply, power stations, then cities and offices, factories, agriculture, transportation, forestry. How this will help sustainability means, let's see the offices and cities, the power on of street lights based on AI, it will do it. If your light is decreasing, let's say in the summer, what happens? The light nearly about up to 7. In if you come to the sometimes even 5:30 it will get dark. So the lighting has to be done based on that. Now that AI model will choose when to light on, light off in the streets or in offices, so we can have energy efficiency. And when the process of data employs some let's say factories, when you implement AI, what happens in the factories or industries? There is an efficient use of resources, so that what there is an impact on resources using. There is a sustainability. And when you design an AI ML, so that can help us productivity increase, yield increase, resources utilization, all things happens. And even agriculture. In agriculture, our case study is an example for an agriculture. And the transportation. I said in the transportation, in the previous example, I said the routing, delivery of parcels to the homes. Yeah. So similarly, that helps us. Use of fuel consumption, a reduction of by using AI and algorithms. And whereas sometimes in sleep mode, everything will help us for sustainability. Now, that AI and ML algorithms will help for sustainable development. Directly, it won't help, but we need to develop it in such a way that it will reduce these things. So while developing any AI algorithm and ML algorithm for sustainability, we have to choose the consideration of economical, climate, and this social, productivity, all those things we need to consider. Okay, let's see this AI for environmental protection and development. So wastage of water, we need to consider. By using embedded system, by using AI, we need to consider the usage of water. Similarly, is any leakages in the industry or any pollutants that are combining with the water, that has to detect the AI so that we can reduce the environmental impact, because the pollution makes water pollution happen by using the industrial wastage. If you use a correct AI monitoring the pollutants coming from the industry at what time, how to reduce, because the continuous monitoring is necessary. How we do it? By using AI tools and embedded systems, we can look at it is changed catalyst to reduce the pollution while from the waste from the industry to the drainage, there is a filtering process will be there. They will do the filtering and they will release that water. So at that time, we have a embedded system and AI intelligence system to monitor that filter section. If there's something has happened there in the filtering, because the filter may change, the catalyst may go, or it's not working, it may increase something. It may give information, alarm, so that that can be repaired, or automatic repair will be done at that area. So the contamination will arrest. So that will be less effective on the environment, that's what water pollution or something else. So that has to be considered. Not only water, that energy efficient, fuel consumption. If you look at the agriculture point of view, we need to increase the yield. If you go for pesticides, when to go for pesticides, we don't know. When you deploy sensors in the agriculture field, and based on that, whether really it is in bugs are happening coming, it will dispense that fertilizers based on the bugs there. Efficient use of that. If you use more entirely, it will that is a pollutant. So if we use effectively, we can reduce the use of fertilizers. That will impact the environment. So when designing the system in such a way, we need to consider all the things, cost, environment, then we need to design. So in everything from the product development, we have layout design, prototype development, firmware development, destination validation, and product development. In all cases, while doing, we need to consider it. Yes. Yes, if you see, it's a one by one linking. Without directly, we won't build in hardware, because we have to simulate different simulations, timing simulations, power simulations, whether it's correctly working or not. All the things we need to do while developing prototype development. Then designs, the size, what are the materials we are using, yeah, then we go for it. So directly we won't develop and testing for hardware, because directly what happens if we do is the best of cost. So that what generally we'll do is we'll simulate first in the software itself before directly building a product. Then we go over one by one, so that the less impact on the environment. So let's see it's an example of case study. If energy efficient point of view, let's use now ChatGPT, what it is running, even though the AIs are running, what it consumes generally. If it's GPT, ChatGPT, what it is, if we're running an algorithm of LM, it will require more natural resources. It needs a huge system. Huge system means for developing that system requires materials, element, the ICs, boards, all those things. To run that machine, we need power. How much power it requires? If you see that to run that model, it requires a huge machine, computation, what we say in cloud computation, all the resources, servers, all those things, TPU, GPUs. Yes, it consumes while running. How much? While running, it generates heat also. But then what happens? We need to cool that one. To cool that one itself requires millions of liters of water here. We'll say it's a simple click on here. By using a GPT, what we'll do is it's a simple con. It will come with 2 minutes, answer everything fine. But in the background, when you look at there, it will run on a big machine where it will generate a huge heat. We need to require to cool the system. If you see in our system, there is a fan, cooling fan. Yeah, for a small system, but there is a big distributed system requires more water. So that those things here is specified here. Consumes millions of water while training models. For what? It's for cool the data centers. It generates lot of heat there. You need to. So the interface 10 to 50 queries used. When you GPT, ChatGPT or Gemini, whatever it is, when you ask for 10 to 50 queries in our system, by opening Gemini, we'll ask our 10 queries. It will consume nearly 500 milliliters of water to cool that system. A massive amount of very needed resources, and the numbers are hazardous. So this is what case study how the sustainability, even though it's an AI model, will give all those things, it is an impact. Yeah, if you see the estimations, what we'll see will consume nearly of cubic centimeters. Yeah, of course it's for AI. Similarly, when you use the cloud integration for an embedded system, we use the models there also. So we have to minimize in such a way when to compute, when to run, and when to sleep mode, so that effective energy utilization is necessary for sustainability. Yeah. So this is the here you can see in the picture the estimated for GPT interfaces in different states of US while running the GPT. How can sustainability and energy efficiency? Let's see if this is one more case in when you design a system, embedded system, that helps sustainability. Let's say AI driven energy efficiency. This is a case here. We'll build a smart building management system. What happens? The light on and off are devices inside the house, on and off. It's a smart based on the AI. So it won't on unnecessarily, so that there is an effective utilization of energy, so that we can reduce up to 30% of energy. By using our embedded system and AI, we can reduce. Similarly, for industrial process, let's see. There also, what happens with continuous monitoring of the sensor data or pollutants? Yes, and by using AI, when to switch on the unit, when to stop that unit, when to be in sleep mode, there is a switching, when to repair, all those things, because we need to diagnose the manufacturing machines. So when it is a problem in the machine, the yielding will be very low. So when identified by using AI, what happens? The repair will be done. Sometimes it is automatically, or by reminding, it will be done manually also by indication. So early detection and early repair, what happens? Will reduce energy, and we can get more yielding also. It's a grid management. We can use this AI for grid management, reduce energy cooling its centers by 40% of grid. So here how this AI will help in energy efficiency sustainability, the waste tracking, waste management. So you can look at here the garbage, sound sensor, and the humidity sensor, gas sensor. Here these sensors will help us to get the data will be sent through Wi-Fi artificial intelligence. Continuously we'll get the information of these sensors. When it is the waste happens, based on the artificial intelligence, we have the control system there processed here. The waste sorting robots will dispose, all those things will be done. When it is filled, bin filled, automatically it will give the indication, and the transportation will be done, and it will go to the dumping station. There the waste sorting robots will do the sorting of waste. So if you look here, the waste came from home or from industry, it will detect accurately, so that the transportation of waste will be done. If you don't have such a system, we don't know when it comes and when it goes. So sometimes there is no wastage, but still the transportation person come and goes. So it's a waste of energy. Now, if it fills, then he comes and he go. He take care of that bin waste, and it dumped. And there is a robots. The sorting of waste will be done. The plastic, glass, wets, all those things done by the robots. There is also an AI, embedded system and AI. In robotics also we have those things. So those things will be done. So what happens now? The energy, what happens mostly, the waste management will be done effectively, and reduce the spread of disease will be done because we have some gas sensors, order sensors in this, and there is a labor expenses. In previous case, what happens? The labor will come and go even though there is nothing. It is there. Then automatically, what happens? The reduce in the pollution, and this prediction through AI. What this is one more case. What we are discussing here is the sustainability will help the waste tracking and management, because we design an embedded system and AI for waste tracking and management, so that the sustainability happens and the profit increases. Yeah. So renewable energy reservoir, we can also hear historical data production. Proceed here, the wind turbines. Here the production happens with the data from measuring the weather data and numerical weather conditions forecast. So now with the forecast of these things, renewable energy, the blades has to twist sometimes. The blade angle has to change because the wind won't become at the same time. It has to change. So there we'll use an embedded system to detect the sensors, the air, wind flow, here, the wind flow, and then actuators to turn the blades so that the efficient utilization happens. So we have more productivity here. There is no loss. We have more efficiency generation of energy, and based on the weather conditions also important. And based on weather conditions, it has to tilt the like maybe solar. There's an cyclone. So based on that, by using of this artificial neural network models, so if there is a cyclone happen, the production has to stall or to continue. The transportation of electricity poles whether to continue or stop, because the prediction gives us the cyclone is coming with with some speed. Let some 100 kilometers per hour speed. It may damage the lines also, since no transmission of energy. What happens? It will damage everything, the production, everything. So that what happens, some necessary things will be, a necessary protection has to be done with this already prediction networks. So that in the grid, what happens in renewable energy, by using these things we can increase the production. Similarly, this will increase yearly. This is what it will increase in agriculture fields, increase the crop yield, operational cost, reduces waste. Yeah. So this can be happen by using an embedded system and AI for sustainability. Yeah. Of course. Yeah. Yeah. Let me see the time. It's nearly 4:47. Yeah. Yeah, if you see the embedded system of how it's going on, it's in some as a statistics point of view and the demand of embedded system, so that how it should be, because we have to use the cloud embedded system in our daily life, right? So how it is going on and how we need to consider, because it's an ethical responsibility for us also, social responsibility for designing any embedded system or a cloud-based using, it should impact for our lives. Yeah. Even though there is challenges, performance and sustainability. If you need a performance, what happens? We have to use the resources. The using of resources, what happens? Depletion of the resources. Then the sustainability is a problem. You got performance need resources. Using of resources, depletion of resources. When the depletion of resources happen, for the next day, where is the resource? So the performance versus sustainability is in optimizing those things needed. Then cost implications. The higher initial cost, but it has to be longer term saving should be there. If I spend from some designing or something, I spend from 1 lakh or something, it should be used for at least at least 5 to 10 years, then it will be good. Otherwise, in the next year, again, he has to spend for designing on an upgradation for 1 lakh. What happens? Cost implication. So that it may be initial cost, but it should be sustained for longer period. So if you design something, for 1 lakh, at least for 10 years, then it will be okay, because for 1 year it will be 10,000. It's not a problem. If it is not like that, if your design is 1 lakh rupees for that one, and next year again a 30,000 for something like that, what happens? It's a cost implication less. So that has to be considered. Sometimes the initial cost and long-term savings need to be considered. Then emerging trends. The most thing now what we are doing, the computing, green computing, so that there are no pollutions. Edge AI. Why Edge AI we are using here is the computation on the cloud uses more resources because it will compute on a cloud machine. But when Edge AI means the computation of AI model here in the node device itself, in the local, edge instance local, so that it requires less power compared to that one. Even the small application, when you run on the cloud, it requires more resources, more power, more energy. Okay, even though it is fast, it utilizes the resources more. So we need Edge AI, yeah, energy efficient algorithms we need to use, so that we have some sleep modes, when to on, when to make a decisions, when all those things, timings we need to consider for more energy efficient. This is what in future, how these directions, challenges happening in future, the sustainability, materials and design innovations, a circular economy, then sustainability. So when you look here, majorly the embedded systems we design is limiting the resources, limiting the computational resources and the battery power. In sense, using ultra low energy for our embedded system, so the unnecessary connections will not be there, unnecessary of computation will not be there. Yeah, we have to reduce the power as much as possible because low power. Then harvesting system means harvesting in sense, how to give that energy. For running a processor we need a power, reading data we need a power, yeah, computation of AI model we need a power. In each cases, how we can reduce, how we use the resources of environment friendly, these are the things we need to consider. Yeah, so with that with this we need to conclude few things what I said, that AI, the sustainable design in embedded system means what? When you design an embedded system for that will reduce the environment impact and enhance efficiency. At the same time, energy efficiency, technology, and eco-friendly practices has to be done. So we'll get how to do it, all those things. It depends upon, while designing it, the embedded system, we need to consider. We are designing for agriculture point of view there, from where we'll get the energy. How much power we are going to use for agriculture. Whether through battery or solar powered, yeah, which processor we have to use there, and how to dispose, how much power it consumes, sleep time, everything, because everything has to consider for sustainability. If you design their embedded system with a large board, what happens? It will be visible, it will be distributable, it require more resources, all those things. If large board means it require more power also. When you go for ultra small devices, so generally for ultra small devices it uses less power only. It will be energy efficient. The size also impact. This requires more energy and this requires less energy. That also one more impact. So when using for IoT, which one we can use? those things we need to consider while designing an embedded system. Yeah. Is there any queries, please? This sustainability in embedded system design. Is there any queries, please let me know. Of course, it's point of view somewhat it's vague, but still more impact while designing. It seems to be vague, but when you look inside, it is more impact while designing. It's an ethical responsibility for a designer that the low power has to be there, uses of resources, then how this embedded system will increase the efficiency, yielding, conservation of resources. Everything has to be considered because the sustainability is a major problem right now in the entire world. Exhausting of resources happening there, yeah, pollution, energy, the span of a human being are reducing due to pollution. Yeah. So when this system is designed, this impact will be helpful to that. At the same time, the embedded system which we design, that has to be sustained for longer period. Now, what we design something else, that should be used for 10 more years or 15 years. Then that will be good. Otherwise, you are designing a system that can be used for only for 1 year. The next year again has to change. Again. So while designing an embedded system with a sustainability, we need to consider one thing is long lifespan. What is this? Long lifespan, then enhancement and future enhancement. In future, we can able to increase. Yeah, future extensions. We need to consider all those things. In future, how can we use that one? Can these resources can be used for the future generations, that embedded system? That also we need to consider. So major the batteries, whether we go for lithium batteries, yeah, this small things also we need to consider. If we consider effective way of implementation, we need to consider energy, resources, longevity, yeah, span of that embedded system, how much reduction, and how much consumption, efficiency, yielding. So these are the things we need to consider while designing a system. There is a leverages in some things, challenges because performance, sustainability, cost, then resources, span of life. Span of life means what happens? It should be upgradable. Upgradable means we need to include more resources here now itself. So it will increase the cost. Like that, everything is some trade-offs there, challenges there in designing of embedded system. There's sustainability. Yeah. Please, any queries, please let me know. Hello. Hope you can.
Dear participants, if you have any queries, kindly unmute yourself and ask, or else you can post your query in chat box.
Yeah. Yeah, we'll see for 2 more minutes. I hope you.
No queries, sir.
So okay, let's see. Hope all well.
Thank you so much, sir.
Yeah,
You
thank
have
you.
enlightened all the faculty members, enriched with embedded system basic introductions, and followed by cloud integration of embedded systems with AI. And it has been how the AI and embedded system integrated with the different application areas you covered, It was a very nice session. And the second session you have covered with sustainable design embedded systems and AI. It is also very nice. Hope all the faculty members has gained knowledge regarding this.
Yeah,
Thank you so
actually,
much, sir. Thank you.
yeah. Yes, thank you for your patience. But actually, it took more time actually. But anyhow, with short span, we do have a few details, brief details, I have showcased in the people in this session. Thank you for your patience to listening this. Thank you. Have a great day. Yeah.
Thank you, sir.
Yeah. Bye.
Dear participants, next session will commence in next 5 minutes. Kindly please be in online. Next session will commence in next 5 minutes. Thank you.
Hello, Hemant sir.
Yes, sir. Sir, is I audible to you, sir?
Hello, Hemant sir.
Yes, sir. Yes, sir. Sir, am I audible to you? Yes, sir. Sir, am I audible to you, sir?
Sir, Hemant sir.
Yes, sir. Sir, I'm in the
Hello.
meeting, sir. I'm audible to you, sir.
Sir, your voice is not audible, sir.
Yes, sir. I'm audible to you, sir.
Your voice is not audible, sir.
Sir, I'm audible to you, sir.
No, sir, no. Kindly check your mic, sir. Your voice is not audible.
Yes, sir. Sir, am I audible to you, sir?
Yes, sir. Yes, sir. Yes, sir. No, it's okay.
Yeah.
Yeah.
Okay, sir. Okay. Yeah.
I would like to invite Hemant Kumar, sir, Embedded Engineer Data Point Solutions, Hyderabad, for a take over the session, sir. Please take over the session, sir.
Yeah. Thank you, sir. Thank you. Good evening to one and all. So myself, Hemant Kumar from Data Point Solutions, Hyderabad. So it's my pleasure to have you all in the session and the eminent faculty members and the educators in the session. So let me start the presentation with my PPT. Sir, is my PPT visible to you all, sir? Sir, is my PPT visible to you all?
Not yet, sir.
Yeah, okay, sir. Yeah, sir. Right now it is visible to you all, sir?
Visible, sir. Please proceed. Make
Yeah,
it to full
thank you,
screen and proceed. Yes, sir. It is visible now.
Yeah,
Proceed.
okay, sir. Yeah. So today I want to talk regarding about the revolution. So revolution is nothing but like the change. So transforming the everyday life. So the topic is nothing but the future trends in the embedded systems and AI industry 5.0. So a revolution, that is a building, that the building is nothing but the there is a every revolution we have a starting revolution like 1.0, 2.0. So the basic version of 5.0 is nothing but the 4.0. Before the 4.0 funeral, nothing but the after the 4.0 we created the 5.0. It is nothing but the human and the mission interface. Like we all see the regularly the every devices like embedded systems, every devices. The automation is nothing but the software is nothing but we created a device that is nothing but to do a particular task. So here we created some sort of devices that is doing a particular tasks. When we integrate the same devices or when we integrate the embedded systems with A in the 5.0, so what exactly will happen? In the today era of industrialization, nothing but the every industry is booming. Like the every industry is creating the new technologies, like the new products. So automatically, when it comes to the consumer, so we need to create the every device or a prototype or a model or a working principle upon the consumer needs, right? So the technology is booming in such a way that the consumer need to do, or the engineer or like the working persons need to understand the consumer needs, whether the consumer wants this type of model, whether the consumer want that type of model with that type of applications. So basically, when it comes to the starting basic models to the industry 5.0, so I am talking regarding about the industry 5.0. So industry 5.0 is at present industries what the trends is going on. Like the industries are going to be with the new products, the technology development, and nothing but the assessments, the way they want to, the way the consumer need, the way the consumer want the products in such a way. Right now, starting from the basic elements, like we are gonna having some sort of sensors that is nothing but the automation, or we gonna having some sort of sensor like a camera module or a normal controller. So normally, what exactly we do in the last era is nothing but we just the model will give some sort of inputs and outputs. That is, but what we take the inputs, what we give the inputs, the output is according to the inputs only itself, right? So, so I am talking regarding about the industry 5.0, in which it is nothing but a human-centric industrial revolution, where the manufacturer must be with the society. It's nothing but when we take an example like a Tesla. So the Tesla or any new innovation, the technology is in booming in such a way that the industry needs technology, and the man and the consumer wants some sort of application applicable new applications. Like every span of time, we're gonna having some sort of new technologies upgrading every individual products. Like that, when we having a human centered AI, nothing but a human plus mission, that is nothing but two interface, that is nothing but industrial 5.0, where the industry needs this type of products, where the working of principles getting very upgraded. Let us assume like in the olden days, what in the olden days, what in the like previous days of 4.0 or before the 4.0, what exactly what happened. So usually every component or every working principle be be a set of rules, nothing but they want to do a task that it. When compared with the humans and machines, we want to reduce the sizes of the products. Normally, when we are getting the huge impact, huge like industrial revolution, what I mean to say is, where we having our daily lives, where we see the daily so many products that are being upgraded day by day. When we see the earphones to the earbuds, like change, some sort of change occurred. When we compare to the different type of machines what we're using in our homes, some are automated, some are enhancement like future automation, some applications are rechanged in such a way that the industry needs this type of automation, where the humans need or the technology upgradations has been done, and it aims to create the safe, inclusive, and respectful environment for the employees also. Because comparatively, when the citizens needs the upgradation, automatically when we created a device, some sort of people needed the device, right? When we are going to upgrade it, like when we see normally so many devices, example where some sort of new upgradation our automobiles industry, our machinery industry, our technical aspect, like coming to a different elements. What I mean to see is our daily lives. So industry is nothing but the human with missions has created in a new revolution, that is nothing but industry 5.0, where the humans created as per the citizen requirement or as per the user requirement. We gonna having a small size of chips, we gonna having a small reducible sizes, and we having some sort of application metric models where the user needs some sort of applications itself, because in every product they need a lot of applications, because as a product itself having some set of applications. As the user requires, the user can create. As the user requires, the user can give the inputs. Upon the inputs only, they created different types of modules in the 5.0. Right. So this is nothing but the industrial revolution 5.0, which a larger view. Let's get started with the new revolution. So the industrial revolutions, in which 1.0 and the industrial revolution 2.0 and the industrial revolution 3.0 and industrial revolution 4.0 and the industrial revolution 5.0. Let's assume the olden days. So we gonna having in olden days every like we gonna in the olden days the human efforts, fully with the human efforts and with animal efforts we done the tasks. In every task we need some sort of human effort with the animal efforts, or like that happened in the olden days. What exactly done in the industry 1.0? So let's get into the deeper section of industrial revolution. Okay, so let me give you regarding about the 1.0. So the industry 1.0 is nothing but the age of mechanical production. I'm having a headline in which the age of mechanical production. It is in the era of 1760s to 1840s, where we removed, means in the sense what we created, we are used on before that we are used the animals and human efforts until that time, until that late 18th century, right? We're using with we don't use any emissions or anything, we just use it only the animals and human efforts, right? So what we created as a mechanical production in the industry 1.0, we created the mechanized products which use it to create some sort of goodies. In the process, we use it the steam and water. So I'm exactly saying regarding about the upgradation. Like when we started the devices, when we started creating models, before the model we don't have any exact any like anything what we needed. So after the mechanical production of the first industry 1.0, we created some sort of devices, nothing but some sort of applications elements. So upon that, before that, we having a manual process. We need some sort of heavy labor, large number of labor, large number of animals to do a task. Nothing but to do a process. What exactly is when we compared with a smaller efforts? Because here, what we created a industry 1. What exactly industrial 1.0 done? Industry 1.0 is created to minimize the human efforts. The humans, he's given the appropriate response, or he's given the key to control the missions, where the missions do the task. So we know that basically we can do all the tasks, like what the all done needs, what we exactly want, and we can prepare it. But sometimes that is nothing but a heightened moment. Sometimes we need of heavy labor and heavy production that needs large efforts of humans. So the 1.0, when it is created, it reduces the human efforts and created a devices that works with the human inputs. Right? What exactly I'm saying? Human inputs. So when the human give the keys to do the task, automatically the machine working on it. So that is done is nothing but industrial 1.0, where we having a lot of old devices what we used in our olden days, where the human efforts started, you have human efforts being slowly down and the machines being slowly upgraded. So that is the era where our mechanical production started, where we have created so many devices from the manual, where we have entered so many devices with the missions. So let's get started with what exactly done after industry 1.0. So industry 2.0, let's talk regarding about the mass production and electrification. So what exactly done in the industry 1.0? We having a type of missions, or like we created goodies that can work process. We don't have any electrification. That is nothing but it is done in the late 19th century into early 20s. So what exactly created? So we created with a electrifying signals where we extend the power, where we given huge set of power or huge requirement of power to the devices to be working in a working condition, where the assembly line techniques been developed in that era only itself, in which we gonna having a products where we created so many products, because on after every mission can create the product, but when comes to the last set of missions, when comes to the large set of equipment, when comes to the last set of production, so we need that electrical signals, nothing but the electrification. We need the electrification. What exactly we need? So the electrification is used for the mass production of goodies or like items or products. When comes to a normal industry, when comes to the normal industry, what we are taking, let's assume some sort of industries. When comes to the oil industry, we have so many. We have used so many, like when comes to the oil industry or when comes to the steel industry. So the steel industry comes to steel industry, that the starting rates of the steel is like the steel cost is very high in the range. After some sort of upgradation of industry, the steel rate is getting cheaper, where the mass production increases. But the production rate is going to be increased in such a way that the product cost automatically get cheaper, right? Because when it comes to the production, the mass production, what I'm going to tell you regarding about it, because the production itself, when we having a requirement of production in a heavy way, automatically the mass production leads to the cheaper amount of goodie, nothing but a product. Automatically when you have a huge set of production, and automatically in the industry 2.0 itself states regarding about the some sort of different industries like uh, cement industries and some sort of like fuel industries. Originally we having a oil, like what exactly I'm saying, the oil in which we created some sort of like we refined it as it a petrol, as it a diesel, after the industry 2.0 itself, because when the mass production and electrification has done, we letting it an idea regarding about the bifurcation, nothing but a uses of a fuel in a such a way. Before that we used to use the coal, nothing but the coal, what mean to say is for a production or for implementation or for a general working principle also. All right. So let's tell you in a deeper regarding about the industry 3.0. So the industrial revolution 3.0 is nothing but a middle revolution in which we are having a transmission of analog and mechanical process to digital automation. It is nothing but the regarding about the controllers, microprocessors, or like the technology enhancement in such a way that we use electronic components, nothing but the electronics what we use. Because when we do a particular task, or when we need when we need to do a task, we must require some sort of components. The age of digital automation is done on industry 3.0 on the time of at least 20s itself, mid 20s, starting to mid 20s, where we created the different types of like electronics components and computers, and we used in the information technology, and the revolution is started in such a way that the booming technology goes on with the different uses. The pattern includes nothing but the elements in which we do particular tasks or we do some sort of task or working principles. So let's have in the classification regarding about an example with a sensors, where the electronics being upgraded in such a way that we can calculate regarding about the temperature, regarding about the humidity, regarding about the temperature, regarding about the count, the body itself having some sort of advancements. Nothing but the electronics is upgraded in such a way that the controllers just calculated, or the controllers the controllers also have a vision regarding about how the it having the formulas, the set of rules or set of principles what the user give. Automatically, what exactly the controllers or the electronic components do is the electronic components having a principle that worked as per the user, right? So that is the industry 3.0. What exactly happened? The age of digital automation done. And what exactly in the industrial 4.0? The age of cyber physical systems, where it is nothing but the itself the figure the diagram shows you regarding about it, regarding about the connection, regarding about the big data, regarding about the automation, regarding about the IoT, regarding about the system integration, and regarding about the cloud computing. So let's get deeper into the elements. So the 4.0 revolution is the revolution where it leap forward from the digital automation industrial 3.0. So what exactly here I stated regarding about the connection. At least we don't have any connection regarding about what we are going to be work on, because uh, we don't have any interconnection regarding about the data transformation or data receiving or data center or anything. We just having a principle that work on. When we open the principle and we on the switch, we the process we go on and it will start and it will, that's it. When it comes to the industry 4.0, it is connected, it is created a connection between the user and the working principle, where we can having an automation by our mobile or by our laptop or by our any other, by using some sort of APIs, where we created in a such a way, such a way that we can control it with our mobile, we control with our user, nothing but the user can control it, right? So regarding about the automation, because everything, every component or in every industry, the automation has led in a such a way that every individual industries or a refinery industry or electrical industry or electronics industry or a machine industry, everything is a future extent. Every industry needs from future extent. So what exactly in industry 4.0 done? So the industry is led to the automation, where they created some sort of inputs already given to the processor or controller. So normally when it comes to the refinable equations, nothing but when you take a machinery industry or a cement industry, when it comes to the cement industry, it leads to the production of around 25,000 or at a particular number of 25 to 35,000 of cement, or like we need to do in a month of time it a production unit. So what before that what gone? So before that, the usually the labor having some sort of shifts. The labor usually working for a large hours, where they use it to control the machines and getting the huge production. So what exactly done in the industry 4.5.0 4.0? It leads to the automation, so that the machine automatically works with a time shift, where where the user can check whether it is doing the task in a good way or not. So it leads to the automation in such a way that user having a user friendly experience, where the user can check upon the time values. And here comes to the disadvantage, here comes some sort of disadvantage regarding about that the labor effort is getting minimized. But somehow when automation comes in, the machine industry is getting booming in such a way that the people, the technical point of view, the industry is getting upgraded. Let's think regarding about what exactly in IoT. So IoT is nothing but Internet of Things, where we can automate it, where we can get connected usually. So the internet, what we are accessible with a mission, nothing but the way we use it to connect it, the way we use it to connect or way we use it to control it, is nothing but done by the IoT itself. It is nothing but a data. What exactly we needed when we given a some sort of predefined functions, or when we given to some sort of instructions, automatically the controller works when we give the data with some sort of APIs. In any resultant analysis, let's start with a small an example like small an example like regarding about the strength. of IoT. When it comes to integration, so when we are integrated the controller or when we input, so the industry give you some sort of alerts before that. So before the IoT, we don't have any get some sort of alerts regarding about any equations, or we don't get any predefined functions that this is happening. We get this is data. So what exactly IoT is doing? Nothing but operating everywhere, operating anywhere from the world itself. So it usually getting the huge set of information where it tends to sorry where it tends to getting huge large number of outputs. Let comes with big data, because data is big data. So big data is nothing but what we get the accurate results or the prediction analysis, nothing but the we are giving the inputs, nothing but what we can give to the mission or a controller in such a way that they will work on. The way the system integrated in the industry 4.0, where automatically we're getting huge level of perception, where the integration and the cloud computing, where the data can be stored. This is the era of 21st century. Continue to evolve, revolving the manufacturer and the business operations worldwide. It is upon the business needs and strategy what exactly done in the 4.0. So let's start talk regarding about the 5.0, the age of human machine collaboration. It is nothing but it is building upon the foundation laid of industry 4.0, but we created as per the human capabilities. Here in which 5.0 is nothing but what we do in the daily lives as the human need. The human interacts with the machines. The human interact with every machine and do the task, nothing but do the process. Where every machine and human combinedly integrated with advanced tools like IoT, like IoT and big data, uh, right? Artificial intelligence, machine learning. These are the concepts what integrated the human and machine. Where every in the industry 5.0 we created all the devices in a such a way that every device must having some sort of rules where the user friendly devices. Presently we are having some sort of cars, nothing but having the operation automatically. When you see the new industry, nothing but 5.0 having been tends into the real time existence, where the automatically the car having its own path, it can travel with a path what it's shown. That is nothing but a human machine collaboration. The human given a command regarding about it, the machine also collaborate with the human and having a intelligence to think in such a way that it can travel in a path where it shows the coordinates. Alright, regarding about that industry 5.0, where human and machine collaboration, in which it tends to the tendency regarding about how we traveled in such a way, where the connectivity, where it comes to the automation, where it comes to the smart systems, nothing but the devices having the adaptability to think regarding about the user options. The industry 5.0 tendency having a much tendency regarding about the human capabilities of decision making. Yeah, it comes to the progress of creativity and intelligence when compared with the before trends. We getting in a such a way that the era is a new era where the new level of perception is going on, where the industry 4.0 having a set of components or a working principle where lies the data we given that will be work on. Where it comes to the 5.0, it is nothing but a human machine collaboration in which the machines having some sort like similar to the human elements, nothing but capabilities, where the machines also think regarding about it when it comes to the learning. So let's get involved into the topic, the industry 5.0. So let me clarify regarding about AI. So AI changes the embedded systems in such a way that the devices having the capabilities to think and to evolve the process. So normally in the olden days, we don't have any capabilities. The system does not have any capabilities to think. The system already having a predefined functions. When in the present era or the present trends which lends to the AI, artificial intelligence with deep learning and machine learning, in which the machine can understand the human efforts and the human insights, nothing but the human instructions. In such a way, the machine also having a capabilities understand and it already given as per the human instructions itself, right? So regarding about the AI changes the embedded systems in such a way. So what exactly? Let me give you regarding about the example. So the new devices in adaptability. Let's talk regarding about Alexa. So hey Alexa, open my door is a command what I'm given in the olden days. So what exactly done? When we given a command, automatically it will listen the command. When it's having a store value, a recurrent value, what exactly the command having it. When it is mismatch it, automatically it will okay and it will give you the instruction set. So what exactly after 4.0 with AI we have AI created? Artificial intelligence itself created that when we gone into the house, automatically the AI understand regarding about the human entrance. Nothing but the human has entered, automatically the loads automatically open with some sort of sensors. The creation of 5.0 with AI in such a way that the automation done automatically as per the human needs. So the human efforts will be useful and will be sustainable. But the automation is done and the artificial intelligence has created a path to the mission to understand and to control the mission itself. It is a capable of tuning its functions, nothing but when we having some sort of set of rules in the olden days, the automatically the machine having a set of rules which will only do the set of rules. But what actually AI does, AI automatically having its capability to understand and pre-program, nothing but it is a programmed conditions having it is a capability to understand its deeper section also. So let's talk regarding about key innovations in the AI. So regarding about the edge AI, so edge AI is nothing but a real-time processing on devices and reducing the latency and the privacy and minimizing the cloud dependency. So for an example, for instance, take automation vehicle or industrial automation, where it lends to in such a way that the vehicle, suppose if you take a vehicle is moving towards the front or vehicle is moving in such a way. So the edge AI is a artificial intelligence in nothing but edge AI with a deeper with the is nothing but what it created. It created it's a pattern of way the vehicle can move towards the front. The automation of vehicles is in a such a way that the vehicle can understand the road. It can understand the borders of the road. It is left, it is right, it is right, and there is a vehicle. There is a vehicle in a vehicle is moving in such a way. What exactly the man can do, also AI can understand because AI is nothing but the artificial intelligence and the machine learning itself predicts can understand the human interface, nothing but what human think, what human next to your human think. The innovation of AI in the industry created wonders. When the industry is booming in such a way that the AI, the missions, the controllers can take the inputs as a they can take automatically inputs. Because if you are moving in a vehicle, when we are moving the vehicle, suddenly a big car, also a big truck entered into the like our path. Automatically, man gets stubborn in some conditions, but the machines already what we train get not must not be stubborn there. Automatically, it give a command, it automatically stop. So right now, the vehicles automatically the pattern what we are suggesting or what the trends in the industry 5.0 suggests you people regarding about the high AI use in embedded systems, where we can tend to the larger view, a new level of perception in the AI, in the embedded systems. So that is nothing but edge AI. So let's talk regarding about Tiny ML. Tiny ML is nothing but a machine learning. The models, AI models are optimized for low power microcontrollers. So nothing but consider a small devices like when you already seen your devices in a daily life, like nothing but your smartwatches. It is having some sort of sensors in it. So when you wear the smartwatch, when you wear the smartwatch, it automatically tends to give you regarding about your blood pressure, SpO, nothing but SpO2, and regarding about the instruction set, nothing but how many steps you walked. It is already having a minimal energy consumption with a tasks which is nothing but done by the user. It is nothing but the low power microcontrollers in which we do with 100 kb of information, less than that, around 100 kb to mean by some set of values of information, which is very minimal, and that allows the devices like IoT sensors and wearables to perform complex tasks. Nothing but wearables is nothing but what we wear, suppose like an smartwatch or a wristband, nothing but the way we use it. So that is nothing but tiny ML, nothing but tiny machine learning, where the AI models are optimized. Suppose if we take a very minimal effort, minimal component, or nothing but a band, where we get SpO2, where we get some sort of sensors like how many steps we counted, that automatically doesn't ask the user. It already having it doesn't ask the user to give the permission to send the information. It automatically, when it gets the information, it automatically retune itself and send the information. That is nothing but the tiny ML, where the AI models are tuned in such a way that they're having a set of they're having a some set in which they can send the information without the user effort, where the user doesn't want to give the where the user does not need any instruction to give. The models are pre-trained in such a way that they can send the information without any command. That what we see in our daily life, nothing but our wearable smartwatch. So let's talk regarding about A optimized hardware. So A optimized hardware is nothing but the chips. What way the specialized chips? Because every industry needs the placement of the main chips. Because when we want to do a task, we need some set of components that are placed in the chips. That is based nothing but a controller or some set of boards. So here we created the optimized hardware in such a way that it is nothing but a task performance, nothing but the performance of the user. The user created the user in the olden days. We seen the user created in this much of boards, this much of boards, this much of boards. The large tendency of values, the large tendency of capacitor, resistor, the flow, heavy flow in it. But compared to that, in our trends, new trends, what exactly happened? So what exactly happened in our new trends? We gonna having the new set of values in which optimized in such a way that it comes with a new set of values where we get the relevant outputs. So every device, when we compared with the olden devices to the new washing machine, when compared to the olden mobiles to the new mobiles, when compared to the olden electronics to the new electronics, every electronic device is modified and is given the new set of instructions. Nothing but the size, the area, the width, nothing but the area of the uh, component size is getting reduced day by day by using the A optimized hardware in which it performs the tasks. So what exactly we can done? So while maintaining the energy efficiency, the compactive systems is nothing but the artificial intelligence where the AI and machine learning tendency to do the tasks. So comparatively, AI is nothing but a deep learning where we given the algorithms to perform the tasks. So nothing but when we given an image. So when we given an image, so automatically the AI having a adaptability to image, to set of image resolutions or image classification. So what we exactly done with the AI image classification? So these are the things we gone deeper in with machine learning and deep learning. And the AI having a capability to perform the task in such a way that the automatically the data or the what the inputs they want and what exactly the outputs they want to relieve, they want to get from it, right? So regarding about the machine learning and deep learning in embedded systems, so comparatively machine learning is also familiar to the deep learning, familiar to the AI, but is somehow differ from AI and machine learning, right? So these are the two concepts very similar to it, but the concepts are very similar and they're having the same pattern, but somehow they differ. So let get clarified in the next slides. So regarding about the neuromorphic computing, so inspired by the human brain, nothing but the as the human brain thinks, what the human brain thinks, mimic, nothing but the mimic brain, what exactly it will think. So the computing in such a way that the human brain thinks, having the aspirants, having the values of set of rules that will be done. As an artificial intelligence, it processes from the embedded systems with a limited resources. Nothing but the human analyzation, the way the human analyze is done in the neuroformic computing. As the human brain think regarding about like that, the like a human brain, how it calculate, how it think, like that the neuromorphic computing is thinking in a such a way. Like we've been using in industries, we've been using in our like health industries, in automations, in electronic different way, in a such a way, like different industries. So what exactly done, like the human brain what mimic actually done, the process is nothing but what we actually need. So let's get give you an example regarding about it. So automatically when we don't having when we take an example regarding about a system, nothing but evaluation of a performance of a large mission. So the large mission consisting of a refinery, in a refinery industry, what exactly it will done, the refinery industry is automatically producing some sort of ice, some sort of oils or whatever it may be. So the refinery industry having the missions in which the missions giving the some sort of send the element, nothing but what was there in the missions into the refineries, is having the high set of missions of values, where the brain automatically like a human, automatically the mission like a human what exactly we think, like the mission also think regarding about the temperature, regarding about the existing regarding about the need of the product is nothing but what was there in the mission. When we take an example regarding about our farming, let me give you some sort regarding about our farming. Suppose if we go into the paddy field and take some like measures when we check the plant regarding about the plant is good or not. So like our brain we think regarding about the condition of it. When we firstly check regarding about with array, so that we have an idea regarding about that plant is good or plant is some sort average, or plant is some sort is not good, so it will be not giving some sort of good outputs. So like how our brain thinks automatically, the industry is booming, like the neuromorphic computing, what I mean to say, the neuromorphic computing mimic the brain, where it will understand like the human, it will understand, it will pre-process the functions. So let understand the new era of AI, in which the numeric computing tendency to get the large values, right? So let's give you regarding about the FPGA based AI processing. Is nothing but the field programmable gate array, in which the hardware solutions or the AI compositions, in which the suitable elements, when we compared with the real time processing of data, in which the data having the tendency to move towards the area, nothing but when we having some sort of values, in which the values move towards the to do a particular task or a particular principle, like the FPGA already having the accelerate AI, in which the AI we use deep learning. The deep learning is nothing but when we compared with algorithm like CNN or computation neural network, or we can having some sort of classification like text classification, image processing, or image like change of image. What I mean to say is the AI enables it to do different tasks, computing with the real time values, right? So regarding about that, further we having the AI in the cyber security. So cyber security is nothing but a threat. Already we been deployed, like we been like you've been like seen some sort of different elements in the cyber security. So already we're getting some sort of messages from the our some sort of messages from the research cells, some sort of messages from our network bandwidths also. Like we get a message like don't try to open this type of embedded links. So what actually embedded link with AI created, that getting a huge response, that getting a huge data set. What I mean to say is data set. Already the existingly last few days back also you seen like we used to get a calls. So normally when we get a calls we don't get any information. Normally normal calls we don't get any information. When we get a normal call, that does not leads to any sending of information. So what actually done with the AI? So AI with embedded systems leads to a like a huge impact, where sometimes what is, when we getting a calls, normal calls what we need to have it normal calls, where let an example in the real time, like what you seen in the present trends. So when we getting receiver, and the receiver getting some sort of small set of information, with the AI what they created in the 5.0, when we receive the call, when we pick up the call, automatically it camera operation to the user. The AI is pretend in such a way there is a threat detection systems, in which AI is a main concept in the cyber security, which leads to security threats. Because automatically, let's take an example in so many companies, they're having a projects regarding about the links, nothing but the uh, dashboard with the links. I'm saying dashboard with the links. So what exactly they're having? They're having some sort of around 10 to 1 to 10 servers, in which 6 or 7 servers are real, and in which 4 to 5 servers are fake. So the way the technology upgradation going on and the technology booming, there is a misuse of the technology is going on also. So that's why they created a pattern in such a way that the people, or the people who want to get misuse of the technology may be caught easily. So the cyber security in which the AI what we're using improve the safety. So already given an example regarding about the company's server. What I mean to say is every company having its server. Suppose let assume a server in Amazon. So they're having a data sheet. They're having a data sheet that tends to that they created a server in which the data having data. what they created, after some set of time or some set of days or some set of, like, after some set of months, they want to remove it and they want to add the new server, in which already we already having a familiar with it when we get the concepts, like we already get the messages from the bank regarding about that there is an there is a 2 days 2 days like there is a change of 2 days, the bank servers will not work, like there is a server change, so that's why the banks will not work, the banks under maintenance. So what exactly then, so banks also getting involved is getting banks also having a huge server effect, in which they also needs to change from time to time. It leads to the Amazon also. When it comes to the Amazon, there is there is a also like last few days back also, we have somehow there is a product ordered by the customer around in the 2019 or 2020. He used the product, he get the same product in the early 2023. What happened, because in the server itself getting a information what been restored it. So that's why the links, hyperlinks, now what I mean to say is the application interfaces are nothing but the servers what they created. So that's why every company having its fake and real servers. So upon the cyber security itself, because everyone needs to erupt or misuse the server, they may leads to the disadvantages. So that's why in the AI also we create AI in the cyber security is nothing but a safety across the devices. So let's have the applications of AI in embedded system. So embedded system applications of AI in embedded system is nothing but an automotive, in which the industries tends the missions, where the missions do the particular tasks, in which the all the industries like in the automation, like the controllers or with the chip design, the chip automation, like what we see actually in our phones automatically we having a hardware setup components. In the healthcare is nothing but in the large span of missions, the ECGs. So normally when compared to old days, we don't have any missions that is capable of doing or getting the values calculated and getting the resultant analysis. So we gone in such a way that when we go to the hospital and we take the blood or samples, we need to take 2 or 3 years of time to get the resultant analysis of the person. Where the healthcare industry is upgraded in such a way that we get our results in instant of time. With our mobile phone we can track it. So the AI drives the healthcare in such a way that the person can understand his level of like his level of uh, what I mean to say is health condition. What I mean to say is health condition. The health condition, whether he's having a good side of health condition, whether he's having any compatibilities, nothing but his body is functioning in a right condition or not. So in the same way in the industrial automation also. So in the large span of regarding about the all industries like an oil industry, refinery industry, petroleum industry, like a machinery industry, like a device industry. What I mean to say is every industry is automated with AI. So the missions are getting upgraded in such a way that every mission or every component must interact with AI. So what I mean to say is like machine learning and the deep learning is the same relevant, but compared to the AI, machine learning is quite different. Machine learning is a set of values, nothing but machine is giving the code. Machine already we given a code, so automatically the machine understand the code and do the task. That's it. So AI is different than machine learning, in which AI has a compatibility like a human brain can understand it and do the evident tasks. And comes to the consumer electronic. So every consumer needs the electronics as per the need, nothing but as per his interest. What I mean to say is, so the need, the interest of the consumer given to the appropriate people leads to the new devices with a good working principles. So the AI has created a pattern where the people given their efforts, nothing but the people can think of that what they need and what they assist to the AI, what they assist to the people, like production departments, nothing but what I mean to say is. In the agriculture also, because it's the agriculture, we gonna see the new missions, nothing but the new innovations of AI. So normally when it comes to the agriculture, in the olden days we get the plant. What I mean to say is we get the crop. We used to cut the crop and we used to put the crop in a like in the shelf or something, nothing but in some element, and we gonna take to the deeper to the section of departments where we get check what type we need to pour and what type we need to get the good result analysis. So present AI trends to in such a way that the AI can give you the outputs with a minimal time and with a minimal efforts, but leads to the human effort less, but leads to the humans getting low jobs. But comparatively, when AI is upgraded, the human also automatically can be upgraded. The smart cities the smart cities where we get everything is automated. The smart cities automatically it is having like smart cities where it is the work done automatically by the missions itself with the human collaboration, where the human having a tendency to give the operation set, where the mission can understand and having a minimal brain like a human. It also gives it also gives the same operation set where it perform the tasks. In the retail industries like different in the aerospace and defense also, comparatively comes to the aerospace and defense. So normally when we compare to the olden days of Jet E3 or Jet ECC3 or old flying nothing but flying jets, they didn't having a parameter to get the definable locations. Comparatively, the new aerospace and defense with AI development trends to get the all values, because we having a perception that the jet can know the distance, how much it need to travel, and how much distance between his enemy and he itself, and it will already calculate that how to do the next process also. Nothing but the human getting the predefined instructions, nothing but the human getting the advantages with the AI in such a way that if you do the task in this way you will get this output, if you do the task in this way you will get this output. The AI in which the AI in the embedded systems has been the new level, so that the user can having the multiple set of options, right? The people, the instruction set, what I mean to say is what we need and what we assist must not be the way what we need to conclude. So the tendency to move the tendency to move the values, so sorry, yeah. So the tendency to move values but not lead to any information. So comparatively, machine learning and AI with a new with automation tends to. So the image processing, or suppose any classification, any text recognition. What do you mean to say with with a machine learning? Suppose we do with a sort of algorithms or like sensors, like some sort of sensors. What exactly sensors do? Sensors automatically sense the information. Nothing but it give you the accurate principle what you want to do. Suppose if we take an example of a oxygen or a blood pressure sensor, so automatically in the olden days we just get the beat count, nothing but what I mean to say is your blood pressure is around 100, your blood pressure is around 20, your blood pressure is around 85 to 95, or whatever it may be, the value. What I mean to say is the value what we get. But what actually in the applications of AI done, when compared with the new applications of AI, it will give you the accurate value. Nothing but when it comes to the 94, it leads to some sort of diseases. You need to control your brain. You need to control your heart itself. It will give you the alerts, so the person can understand his the way he want to make it visualize. So automatically in the ARs also, nothing but like evolutions, the different types of evolution, where it tendency to move the components in such a way. So late in the 19th century, in the olden days, we don't having a perception to move the elements. The likewise, when we upgraded the systems in all the industries, it is a related things. Comparatively, we're getting a new glasses also, like comparatively art AU like resolution techniques. Olden days. So the new upgradations leads to all the applications with machine learning. So machine learning with a two principles were supervised and unsupervised. Where the data in which we are giving the data, we are giving the data, so the machine can understand the data. Already when we give a some sort of Excel report, what I mean to say is when we giving a suppose when we take an example called in our paddy field, suppose paddy field, take an example. In paddy field, what I mean to say is when we take a soil sensor or when we take any sensor like a crop monitoring or whatever it may be, it is nothing but it is getting a some sort of values. So it's the same values what we are giving as a two instruction set to the controller. It will take the values. It will take the values and will get the resultant analysis. So like that, it will having a supervised and unsupervised learning in the machine learning, in which the machine learning tendency to do the task, whether the user need to get the accurate values or not. So the report must be accurate or not accurate. It having the two figures itself. It is either yes or no. In which the supervised and unsupervised learning, what I mean to say is, in supervised learning, the machine itself having a data, the machine can understand, the machine learn, the machine will be programmed and will given the successful outputs. Where the unsupervised learning, in which the data, what we are getting the accurate data, we are getting the inputs as a resultant analysis. We are just taking the huge number of inputs. It is not an Excel sheet. We are getting the real-time values. What we need to do is, when giving the unsupervised data to the mission just evaluate the process of exploitation, nothing but process of working, and then gets to resultant analysis. So here, what I mean to say is regarding about the augmented reality also sometimes, in which we use different types of algorithms like CNN, like different types of algorithms, where the reality is nothing but when the AI is having such AI in embedded systems is tends to move in a large span, where we can't even predict because everything is automated in the industries. When we're having a mobile that tends to the new gadget, nothing but the mobile itself is an operational device. It will do tends to large number of devices. Like when we compared with the mobile with a new automation, when we AI, so when we ask any information, they automatically give you the all set of informations. So artificial intelligence is nothing but like a human brain. It is an interactive component. When we interactive principle, nothing but when we ask anything, automatically they reacts with it. So like in a human brain, it may be work on like, but actually dependency like a modules. So regarding about the next slide, regarding about how the challenges to overcome. So we're having a lot of challenges when we use the AI with AI in the embedded systems. So the first challenge is regarding about the processing constraints. That is nothing but regarding about the memory, regarding about the space, regarding about the controllers. So what actually is the AI is upgraded. The missions, what I mean to say is the mission industry. The industries are getting upgraded, but I think the principle of the controller is nothing but the limited principles. But every controller tends to the principle and having some sort of memory. So the memory does not change. So there is a sort of memory. There is a limitations of memory in the challenges. Nothing but there is a challenge regarding about the next point regarding about the energy efficiency. So AI tends to move. There is a risk of the batteries. Nothing but when we use presently we having a all cars. Nothing but we having a diesel cars. We having a fuel cars. We having a battery cars. Nothing but heavy. So when comes to the battery cars, there is a run of batteries risk because we use it to power the battery. To power the battery, we having a automation bikes. We having automation cars. Nothing but that runs on that runs with the electricity. Nothing but not depending upon the fuel. Where the energy efficiency is there is a risk because when we comparatively soon regarding about the Ola S1. So recently we see so many devices of Ola bike automatically gets exploded. Regarding about the new automation tends to the space creation, where there is a minimal space with a large efforts, automatically the controller does not having the adaptability to work on. When we compare, when we give the Arduino, when we give any input to the controller, automatically the controller having some sort of minimum spaces. When we give large set of commands, the controller take the commands and automatically execute from one step. It is having a cyclic process. In the process, if we get the huge level of sensors or huge level of interruption, may tends to the lead of lead of like there is a eruption. Nothing but it will not be work on, where we need to get some sort of upgradation. When comes to the AI, there is an efficiency, energy efficiency also is a challenge in the embedded systems. And regarding about the security, so the use of AI in embedded systems make so many things to be done compatibly by the user. But comes to the efforts, when compared to the new AI what we are taking in the embedded systems, that lend to the security also. Sometimes our data will get corrupted because I already informed you regarding about the servers. What I mean to say is, when compared to servers, when we having a good set of servers, when we having a server also, sometimes servers may get interrupted. Nothing but there is a hackers is going on. Hackers will get the solutions. Nothing but our resultant analysis. What I mean to say is, they will get the solution analysis by itself by using the. So there is a security threat also. So security threat is also the main concept when we use the AI in embedded systems. So regarding about the scalability, I'm talking regarding about the next point called scalability. So the major issue of growing AI is in embedded systems, the data, regarding about the data, regarding about the activities, and regarding about the performance and efficiency. When it comes to the performance efficiency, when we give the large number of tasks and we having a set of rules, so that leads to the efficiency and performance activities comparatively like a brain, like our brain, what we actually think, the mission also think in such a way that it will leads to good thing or bad thing or whatever it may be. It leads to the input output analysis in a higher limit or lower limit. Like the AI, artificial intelligence acts with the deep learning, predicts it with a good constants of values. When comparatively, let's take an example of smartwatch. What I mean to say is explain DNAML, right? Smartwatch. When we take smartwatch, sense the data. What I mean to say, sense the data without the user permission. It sends the data to the mobile or the device what it connected starting at the starting on stage. What it actually tends to the, when we open the app or when we open the interface, we are having some set of values like our heartbeat is our heart count is this much, our heartbeat is this much, our heart blood pressure is this much, our steps count is this much. That's the values, all values give you the phenomenal of a person, whether the person is with a good health or not. That tends to the AI with a good use, and hopefully there's a bad resource also, because if the same data will get to the other person, the person may misuse our data. Our body consists data privacy. As the AI handles the sensitive data on the embedded systems, we're increasing the worry, nothing but the very 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 sensitive data, because every data, suppose if we having a suppose let's take an example regarding about ourselves. So we use it to collect every information from our mobile, like we use it to store nothing but, what I mean to say is, when we capture the image in our mobile, that will give you some sort of satisfaction to us. So it tends to the data privacy also sometimes. So automatically, our camera, nothing but our phone camera, what is nothing but it's actually capturing the images and getting the data stored in the file explorer, all our images. What I mean to say is, our mobile data, or not mobile data, or mobile memory card itself having our data. So the data can't be what exactly we can't even send the data to anyone. But maintaining the data, that will be a worry to our people, like regarding about it. Because sometimes I usually tell regarding about the call slate and the last slate. So when someone as a hacker, like getting a call like hello, like what are you doing? So the same way, when we pick up the call, automatically the call started automatically. What it actually, the hacker the hacker try to enable our camera, try to enable our file explorer. Sometimes you use it to get our message, some sort of not authorized apps also. We don't sometimes we're getting a notification that don't try to open the non-authorized apps. That is nothing but data privacy. What I mean to say is, when the AI handles the sensitive data on embedded devices, there is there is a increasing worry about the maintenance, because we can't protect the data. Because sometimes if there is if AI is nothing but, when AI is interfaced in a good way, so some people may be used in a bad way, because they can hack, they can get the information, same information what we are driving, what we are want to deliver in such a way. So the artificial intelligence in the embedded systems can create the wonders. What I mean to say is, because when we getting the huge number of inputs and huge number of outputs, and like a brain, what actually think and what it actually do, we can't even say that this is a limited resource or this is a limited time, because we having a challenges regarding about the power, regarding about the efficiency, regarding about the security itself, and regarding about the working principle. It will do the working with a good set of outputs and inputs. When we give the good set of inputs, automatically we'll get good outputs. But the data tendency, the way it complete the task with AI, the artificial intelligence, like a brain, that like phenomenon approach, where the embedded systems can't even when the starting, suppose like take an example like starting era, we can't, when the controllers are process, what actually do, it will only do task, and that's it. And after doing the task, we'll just use it to reread the values. And after the slowly upgradation of the next level, we use it to get the data. Slowly upgrades down next level, use it to user use it to give the control with the keys. Slowly upgrade to the 4.0, we having the reality terms, in which the user can give the data, can understand the data. What actually at present 5.0 is nothing but the extent level of understanding by the controller or by the mission, the extent level of understanding by the mission, right? The user can the user can understand how the mission is understanding the user, like how we gonna take the device with us, like was if a variable device, or like a control, or a or our our car, our basic need like laptop, our camera accessibility, like camera keep on different types of cameras, our daily console, like watch different devices. What I mean is different devices, what we use it to see from morning to evening, from our daily lives, what tendency to control, to do the tasks. That will be the phenomenon approach of the AI with embedded systems. And and regarding about the future trends in the AI, the future trends in the AI, in which the automation of embedded systems, in which every embedded system automatically integrates, can having the evaluate approach, how to it can do, and how we want to do, and how it can be actual principle, and how it will get us accurate outputs. It having some sort of elements to do the task repetitions of multiple like repetitions of tasks. Nothing but the system having its values can do the task. Regarding about A enhanced edge computing, in which what we actually do is nothing but when we give some sort of inputs, the edge computing is nothing but an era of artificial intelligence, where it tendency to move the components or to move the principle. And and next, regarding about the self optimizing systems, where the user wants it, user need the this type of components for this use. As a user approach is nothing but the self optimizing systems. And then comes regarding about the augmented reality and the virtual reality, what actually we see in the present trends regarding about us, regarding about the reality aspects and the visual reality, in which what we're taking some sort of different types of classes and different aspects in different industries. What I mean to say is the reality perception, what we going to exist, what we going to run, what we are taking in it. And regarding about the edge AI for the healthcare, in which the healthcare industry is booming in such a way that there will get a large number of values, where we're getting a huge efforts. Like already we seen in the last few days back, there's some set of operations done by the mission, because with the coordination of human, automatically tendency, because sometimes the human efforts also may get an errors, but the machine can't even do it, because as a human we are the person giving the input and output, we are the person who write the code, we are the person you use it to drive the mission to the analysis, nothing but the future extent of it. So that's the edge A for the healthcare, with the tendency to move the process in which the person or the system or the person which used to drive a code, in which the machine will drive the code what exactly the user given as per the instructions given by the user itself, it will done the task. So that's regarding about our this future trends in the AI and embedded systems. If you have any queries regarding about anything, you can ask me. Yeah, guys. If you have any queries, you can ask me. Yeah, we have 2 more minutes. So the people yeah. So you can ask me regarding about any doubts.
Yeah, sir. Thank you. Participants, do you have any doubts regarding this session? Sir, there is one question, sir.
Yeah, sir.
Is it possible for AI apps to work on their own?
Yeah, sir. Normal in the real terms, like the apps can work on, it will get the data, but actually without the human interface, it will not be tendency to move the aspects automatically. When it comes to the user reality, the apps getting the data itself, but not given the actual values until unless the user given instruction to show it, or the user given instruction to move the data. So that is the real time analysis, sir.
Thank you. Participants, do you have any doubts? More doubts? Yeah, thank you, sir.
Yeah, thank
Thank
you.
you, Mr. Hemant sir, for giving an good insight in future trends in embedded system and AI for Industry 5.0. Thank you for your session, sir.
Yeah, thank you, sir.
Harish sir, HOD
Yes.
madam. Good
Yes,
evening.
madam.
Just I'm giving one alert. Just session is over.
Yes, madam. I'm going to tell me. Dear participants, there is an important announcement regarding a quiz quiz test and attendance. Just now we have updated your attendance particulars in the Atal portal. In Atal portal, by logging your credentials, on left-hand side, you will be having a tab called assessment. So in assessment, you will be having a link. So by having that link, you can attempt your examination. So by getting the 70% of the marks only, you will be getting the certificate, and also you need to give the feedback also in the Atal portal about our FDP. So the time will be start from 6:30 onwards. The link will be getting activated now. So it will be there for 1 hour only. I request all of you to write the examination between 6:32 and 7:30 and give the feedback also. Again, you need to come to the session, or you can continue like this only. By 7:30, we can have an valedictory. I request all to attend the valedictory such that the certificate will be generated on Monday or Tuesday. The valedictory attendance is very important. So we request you to attend for valedictory, which will be held between 7:30 to 8. Now you need to write the examination. The link will be opened. So our ID is 17355. 115 988, which was highlighted at the screen. So you need to go the test link and you need to take the test. So the test link will be active for 6:30 to 7:30.
Sir, it is a application number. Actually,
Yeah, that is
participant has
application
to
number.
check each and I think is it same application for all?
This one is the application number, sir.
For all participants, the same
173
application number.
1988 is the application number. And
For all participants, the same application will be available.
Can you post that application number and ID number in our group, sir?
Definitely.
Madam, actually, I think it is better to go with the date. That is from 21/2025 to 25/1/2025. Each and every participant can able to register only one FDP for the week which has been assigned.
Shall we start, sir, exam?
Yes, madam, please start.
So by clicking on the link, they can
the link will be
start the
ended by
test.
7:30. So I request all of you take the examination between 6:30 to 7:30.
All participants, kindly switch on your cameras just for around 10 to 15 seconds, please, so that it will be captured the cameras. Dear participants, thank you so much. You can go for the exam section. Thank you. Session 12 feedback link as posted in the chat box.
Dilip sir,
Madam.
For writing exam, we need to log in into Atal portal.
Yes, madam. You need to log into
the
Atal
portal. On left hand side, you will be there assessments, madam. In assessment, you need to select the appropriate FDP. That is our ID is at last 4 numbers 1988.
Madam, here you can have an options. So go to the assessments and with respect to the application number and date will be there. That is this FTP is been organized from 20 to 25th. So the respective test link will be enabled with blue color. So click on that and it will move to the next tab. You will be, I think it is better to, all of them, it's better to move with any desktop or laptop that will be more feasible to take the test.